and so forth here. Okay, so as you know, this exercise is a tad on the fluid side, and and I think it's been more enjoyable because of that. Paul gave his the update that we'll start with this morning, but I think what we just were talking about is how we want to do the group decisions and things this morning, and I think it would be really instructive to basically do that in one place, namely here, and we'll all be in one major group, basically of decision makers. And so because there's basically one decision that needs to be made, and you'll find out what that is. So, in any event, we'll do that, and then depending on what the decision you make is, there'll be a second inject, and we'll tell you how that one will go as well. So there will be a second discussion of this in any event. So I think with that, Paul, you want to go ahead and sort of recap what the situation is?
Yes. Now, what do you need? Exercise slides. Exercise. The very top one.
Okay.
That's the right one, isn't it?
Is it?
Yes.
Yeah.
That's the right one?
I think
We're good. Okay, thank you. This we showed last night, so I am repeating the inject we had last night before the banquet, but of course none of us remember what happened last night after a great banquet. Thank you very much. So I'll repeat it today, and then we'll have a discussion, and we are prepared for several possibilities for the final inject, which will be the fifth. But we're going to be winging it a little bit here, so that we have only prepared so many slides. So some of this we'll have to describe orally. But I'll repeat what I said last night. So here we go. We've now moved to the time when the rendezvous spacecraft has reached the asteroid. It's June 15th of 2023. It's actually been there a month. So we have an observer at the asteroid. The kinetic impactors, which you chose to launch to move the asteroid to the east, are on the way. They haven't arrived yet. They will arrive when the asteroid reaches perihelion, which is several months away, I think 8 months away. It would be February of 2024. However, there's an important decision to make, and that is whether or not to use the nuclear device, which was decided to be placed on the rendezvous spacecraft. So the story has a few little twists here. One of the two rendezvous spacecraft has reached the asteroid, and it has been surveying the asteroid for a while. But the other one experienced an unrecoverable reaction wheel failure a year after launch. And as we know, that happens to spacecraft. I think we had a recent failure of a reaction wheel, didn't we? Especially a spacecraft that was put together on an accelerated schedule. So that rendezvous spacecraft was abandoned. It cannot reach the asteroid. And it has a nuclear device on it, by the way. The asteroid, of course, is still on course, and it's still on course for an impact near Tokyo, as you have seen in previous presentations. That hasn't changed. The impact location is known to within a kilometer, basically. It's 4 years away. The asteroid is a binary, we've learned. The sizes of the primary is 270 meters, the secondary 90 meters, so it's 3-to-1 ratio. The secondary orbits the binary in something like a 3 kilometer by 1 kilometer orbit. It's a little bit eccentric. It's weakly bound to the primary. So this is an interesting case where we have to deflect an asteroid, a binary asteroid, and the question is, what will happen to the secondary? Or will you aim for the secondary? I think that's one of the choices. We know the size, the shape, the volume, the density of the asteroid, so the uncertainties are basically reduced to negligible. However, the beta factor, which is the ejecta momentum enhancement factor, is really unknown because it could vary from one asteroid to another, in fact. But in the worst case, with beta equals 1, computations show that we would need all 5 kinetic impactors to move this system away from Earth impact. So we would need 5 if beta equals 1. Okay, and I think that summarizes all I have on that slide. These are the basic facts. Now let me also say that there is a nuclear payload on the rendezvous spacecraft, which is nearby. It's a little bit complicated because it has to dodge the moon, which is, in a 1 by 3 kilometer orbit, and it's kind of staying away for a while. But if we were to use the nuclear payload, a nominal distance to detonate would be 1 kilometer, and here we have a secondary that's in the way. Now, however, we're measuring the orbit quite accurately, and so we can time it. And if we time it correctly, I see no reason why we couldn't be 1 kilometer from the primary and more or less 1 kilometer from the secondary. Now, you may ask, well, what kind of delta V would a nominal nuclear device produce? Yes. Brent, you have a comment? Okay, that was a question. But what kind of delta V would we get from a nuclear device of 1 megaton, I believe it is?
1 centimeter per second.
About 1 centimeter per second is on the order of that. According to, now that's at 1 kilometer distance, more or less. We've done these calculations. And the moon, being much less massive, would receive a much greater delta V. In fact, a delta V that would be much greater than its escape velocity, and that is the comparison that we used to decide whether the moon would disrupt. Okay, so we believe that the moon would be destroyed if it was a kilometer away from this detonation. So that's the situation. It's a little complicated because of the moon, but the question for the decision makers is what to do, because we have the option of using the nuclear device, and yet we have the kinetic impactors on the way, of which we would like at least conservatively 5 to hit. So the question to the world leaders then is what to do. I want to show the last slide I had, which is kind of the overall picture where we are. So we are here with the rendezvous spacecraft just having arrived, and the impact is still several years away, and the kinetic impactors are this third arrow here. They have been launched, they're on the way, and they're 8 months away from arriving at the asteroid. So that's the end of my inject. Yes, Andrea.
One point which has not been addressed but was contained in our bullet points from decision to make, and I had the impression it was approved. Has it been studied the possibility of using the kinetic impactor on the satellite? Because this gives an option which has not been considered. If you first hit the satellite with kinetic impactor, then, of course, it's 27 times smaller than the main asteroid, so it is thrown where it cannot make any harm. Then you can act on the primary without the hassle of the secondary. In particular, can both use kinetic impactors or nuclear device without problems.
Brent.
So just one quick follow-up to that. Even one kinetic impactor that's coming in would impart so much delta V to the 90-meter secondary that it would greatly exceed that object's surface escape velocity, and it's highly unlikely that the secondary would survive being hit by even one kinetic impactor. So the secondary would not be deflected away, it would be broken up.
But the fragments would also be deflected away or not?
Yes, yeah, well, the fragments would have some velocity, yes.
So I think there may be some small fragment of that would fall on Earth. But that is not likely to be dangerous.
Right, I'm not disagreeing with you that we could use the kinetic impactors on the secondary. I'm just pointing out that it would not be a deflection, it would be a fragmentation.
The kinetic impactor has been designed in such a way that the terminal guidance is good to hit something of 90 meters instead of 270.
We could make that supposition.
Yes, yes. It's the terminal guidance is good enough to hit a 90-meter object, yes. I might also point out, however, that if the kinetic impactors hit the primary, the gravitational attraction will take the secondary along with it. The orbit of the secondary will change, but both will be deflected if you hit the primary.
That's why you have to hit the satellite first.
I'm sorry?
That's why you have to hit the satellite first.
No. What Paul is saying is that if you hit the primary object with all the kinetic impactors in such a way that you don't cause the secondary to be ejected from the binary system, then the entire binary system will be deflected as a whole.
Yes.
Okay,
That's
but
correct.
because there is a possibility that the secondary is ejected, this leaves us with an uncertain situation.
You've hit upon the crux of the problem.
So
Yes,
while on
okay.
the contrary, if you succeed in hitting the satellite, then you have many more options.
Fair enough. Well, it's open to discussion as far as I'm concerned.
Except that if you do that, then you only have 4 impactors to hit the primary. And if beta is 1, then you will not succeed in deflecting the primary all the way off the Earth.
Wait a minute, you have 4 kinetic impactors plus the nuclear device. So you try 4 kinetic impactors, if 1 or 2 fail, then you use also the nuclear
You could
device.
use the nuclear device as a backup. That's true.
You have many options at this point.
That was the purpose of proposing 11 spacecraft.
Yes. Okay, I think I'm finished my inject, and we can open it to discussion.
Okay, well, I think we have an interesting one, and I had one question myself. Is the secondary orbiting such that if you actually were to impart a delta V to both entities, you would get the desired deflection? In other words, is the orbit of the secondary in the right plane, and would you be able to time it such you got it to the right place?
Yeah, we've had some discussion over the timing. We have an observer spacecraft there, and so we know the orbit of the secondary very accurately, and we could time the impact of the first kinetic impactor quite accurately, and whatever phase you'd like of the secondary. But after that, we don't know precisely the delta V that you exert on the system. Therefore, you don't know precisely the delta V that you exert on the secondary. And so the orbit of the secondary is somewhat random after that, and you won't have the ability to time the subsequent kinetic impactors. I think did I get it right, Brent? Yeah, okay. Does that answer your question?
It sort of does, yes. And also, if you were to use the nuclear device, would that is the timing of that, it must be fairly critical too. So you would need to know the orbit of both entities to be able to use that effectively. Okay. Okay, so, yes.
Question, I see there's another launch option at day 4. I know it's for a westbound kinetic impactor. I'm curious, would that launch still be on the table to do a kinetic disruption of the secondary? A good and thorough one.
Good question. Brent, did you want to help with that? It's a good thing you're sitting too close to each other.
So, as I recall, there were 2 kinetic impactors out of the original 8 that were not completed in time for the earlier launch. And so, assuming that construction continued on those 2 vehicles, then in principle, they would be available to launch around now. So, yes, the answer to your question is if what I just said is true, then your suggestion would be possible.
Yep. Yes, question over here?
Yeah, well, it seems like the decision was already made at some point to put nuclear devices on the payloads, so that's already happened. It seems to me if you look at this logically, that you wouldn't be playing games at this point, saying let's try hitting the secondary or the primary with a kinetic impactor and see what happens, because you don't know that any of these will work, and there's a probability that any one of them will fail or all will fail. So it seems like you take the most conservative strategy, given that you already overcame the political position of placing a nuclear device, and you would use the nuclear device on the first one. If that failed, then you use it on the second one, et cetera. It doesn't seem logical that you would be...
There's only one
well,
device.
I thought there's only one on one of them?
We only have one device in the vicinity.
Well, you sent 5, as I understood. 1 failed. Now you have...
Kinetic
5
impact.
kinetic impactors, two orbiters with nuclear explosives on them. One of them has failed.
And the one of them with nuclear failed. So you only have 1 nuclear left. Okay, and what's the timing sequence of when does the nuclear device arrive relative to the kinetic impactors?
It's there now. And the kinetic impactors are still en route.
No, but okay, so they're all there. Okay, but the kinetic impactors don't rendezvous; they hit.
They do.
Okay, but the nuclear device is already there.
Yes.
Okay, then it seems to me logically you'd use that first. If that fails, then the other backup option is to come in with impactors. Okay. I mean, I can't imagine any other logical scenario in terms of a realistic.
Yeah.
Just say is that if you use the nuclear device, the will escape.
Yeah.
Then you have to handle the satellite.
Yeah, use the mic, and then.
Well, I have a,
You
okay.
simply cannot use the nuclear device first, because otherwise, what we've been explained, I think is logical, the satellite will escape. That is, the main asteroid will be deflected properly, and we can forget about it. But then the satellite is likely to be on a collision course, or at least we don't know.
no, that's not necessarily
No.
true.
No?
You should use the mic. Yeah, I know.
Okay, no, to correct a misunderstanding, if the nuclear device were used first, okay, the distance from the primary that you need to place the device is commensurate with the orbital distance of the secondary. So all you have to do, and the secondary orbit is moving in, like a several-day orbit period. It's moving very slowly. So this is it's from a guidance and control perspective, it's a very simple process to place the nuclear device at the correct coordinates relative to the primary. Wait until the secondary is very close to the nuclear device, detonate the nuke, the secondary will be completely obliterated, destroyed utterly, and the primary will be deflected, all in one move.
That was exactly what I was going to suggest as a way of making optimal use of a single nuclear device. But the other aspect too is if you do the kinetic impactors prior to the nuke, if you save that as a last resort, you may create a debris environment that prohibits you from using the nuke for some period of time. Not to mention the fact that simply time on station, the longer you're on there, the longer the probability of the higher the probability of failure. If you have something that you can use that's effective, you should use it first. And again, I agree with Brent completely. If you can kill two birds with one stone and time it properly, you can disrupt the secondary and deflect the primary in one fell swoop. The explosion is not directed. It's 4 pi steradians, right? So why not make use of that?
So, hello. Yeah, I have a question here, and that is, I think we should ask where the primary would go if, say, we only had 3 kinetic impactors to strike the primary. I mean, it goes out into the Pacific, and we've learned that tsunamis are not very dangerous, particularly far away, and so I'm just wondering how far away and what the danger from the tsunamis might be if we used one kinetic impactor to hit the satellite and another one failed, and we had, what, 3 left?
We don't know because we don't know beta. So roughly it would be, if beta equals 1, and you use 3 kinetic impactors, you would have moved it into the Pacific, North Pacific, far from Japan. So you've removed much of the hazard to human life anyway, except for the tsunami, which I would defer to Mark on. So
if we
you want to talk about the tsunami?
Well, we only modeled the tsunami in very limited locations off the coast of Japan. Presumably you'd get similar coupling in the mid-Pacific, and you would definitely get strong tsunami in some locations. The entire coasts wouldn't be inundated, but as you saw, it was very anisotropic, the kind of radiation pattern from the tsunami because of the bathymetry and the focusing from refraction. And so there's no doubt that some locations would get a very strong tsunami. Some locations along the coast of North America, probably, and along the Asian coast, and islands as well.
More, Andrea. Oh, I'm sorry. Andrea, you've already spoken. We have Timo.
So suppose we can place the nuclear device relatively easily at that point, as Brent said, and we can have some control to deflect the primary towards the Pacific and whatever remains of the secondary towards the west, which was the more difficult direction, because it's a longer stretch. And then
as the debris cloud has dispersed, can use the kinetic impactors to clean up whatever is left in case the primary fragments. I would think that's the safer option. If we can do the nuclear detonation long enough before the kinetic impactors come in, so they have a clear view of the target, at least the first one, if there are any targets left.
So I don't understand one point. You said east or west. The kinetic impactors can only move the object towards the east.
Exactly, that's why we want
yeah.
to have the heavy object, the primary, going east.
East, yes.
Also by the nuclear detonation, so that the kinetic impactors have an easier case to clean up in case something fails or there's not a full yield achieved.
Yeah, so as Brent said, the secondary would be obliterated if we use nuclear.
And still there would be some debris that
could be debris,
needs to
yes.
be pushed out.
Yes. Yeah, we don't think much. We think that the ejecta of the disruption would just spread out, and this is 3 years before the potential Earth impact. It would spread widely before.
I wouldn't expect that it's dangerous for Earth, but as was said, the sooner we do that, unless there's a dynamic reason not to, then the dust cloud should clear up before perihelion, and the kinetic impactors also have a clean view of the target.
All right, Andrea has a mic.
Yeah, just a comment. I don't want to give impression there is technical disagreement. I agree the nuclear device can be used effectively in such a way that solves both problems, primary and secondary. The question I would like to ask, wasn't it the case where we are given a mandate by political leaders to first explore a non-nuclear option before using a nuclear device? Because this would be doing the opposite.
Yes, I think that's a point worth discussing, whether or not to use the nuclear device.
The nuclear device can also be used later in case of failure of the other method. So I'm not sure we should use the nuclear device first.
Use the mic, please.
I'm sorry, Paul. Oh, okay.
So if you don't use the nuclear device, we still have an undetonated nuclear device on orbit, so you have to blow it up later anyway.
Well, you don't have to detonate that.
Then what are you going to do?
For the nuclear device that wasn't detonated, when we asked to have both sent, we asked to have dead switches. So supposedly, even if the nuclear device that is somewhere in space, we should still be able to, make it explode. I don't know if it's possible or not, but that wasn't my question.
It is. It is possible to detonate it. We can still have control over it, but it's.
So that's mitigated, I suppose. My question is, I understand that you have negative consequences if you use the nuclear device first, negative consequences if you use the kinetic impactors first, and I understand that if you leave the nuclear device in space waiting for the kinetic impactors, it might not work. But could we time it specifically to send everything at the same time on the primary, the kinetic impactors and the nuclear device? And for the population, we can explain that with the calculations. We understood that there would be consequences just using the nuclear device, and we are listening to them, and we don't want to use the nuclear device first, but that there were mathematical proofs that the kinetic impactors wouldn't be enough, and so we needed to send both at the same time. And you would have this solution of a big explosion that would push both of them at the same time.
Don't forget the kinetic impactors are coming in sequence. There's 5 of them, up to 5, and they're separated in time. So I'm not sure what.
So at least one of the kinetic impactors and the nuclear device at the same time.
At the same time. Interesting idea. Oh, but it's a standoff nuclear. It's not buried nuclear, but it's like Bonwi's idea. That's a little bit scary.
By opening a crater, you would, the radiation that's incident on the asteroid orbit would get sourced inward, and it could conceivably enhance the push, although we're getting plenty of push with the device as is, so,
Exactly. Just standoff nuclear is enough to push the primary off the Earth.
But you would have the possibility to explain it to the population that you used both. If you just use the nuclear device first, you're breaking your promise. If you use both, you can explain that you needed both.
You don't need both. That's the point. So are we deceiving the public here? I don't know. Yes?
I'm sorry, maybe it is a stupid question, but what is the probability that we will lose the rendezvous mission, the satellite itself, using nuclear device? So if we're sure that it will be safe or not?
Use the mic, please. Use the mic, please. Oh, it's coming.
The rendezvous ship deploys the nuclear device as a free flyer with its own small control system. So the device takes place, positions itself at the correct coordinates. The rendezvous ship moves behind the asteroid, uses the asteroid itself to shield it from the blast, and then it moves back out to observe later. So this was all planned in advance.
So you're sure that we will not destroy it?
The rendezvous ship?
Yeah.
We're pretty confident we won't. If we did, then observations from the incoming kinetic impactors would provide position fixes and imagery for situational awareness, even though they wouldn't be able to remain on station.
Okay, thank you.
That's a good question. Yes, up here.
I was actually wondering, what was the timing in between the kinetic impactors? I know a time had five
About
days.
5 days.
So in between the first kinetic impactor, if we go with one kinetic impactor first striking the asteroid, how long then would it take for us to determine beta? Would we be able to determine beta before the second kinetic impactor comes in?
It depends on what beta is, of course. But we think it would take only a few days for the observer spacecraft to detect the beta on even the first. Of course, as they're coming in sequentially, we should be able to detect each delta V individually, because it only takes a few days. Did I get that right, Brent? Yeah. Question over here. Oh, and then down here next.
You have 30 million people at risk. You have one solution on station that will take care of it with the highest probability. If you go with the kinetic impactors, and so I think you have no choice but from a technical standpoint, to recommend the thing that works the most reliably. It requires 2 to 3 hits from the kinetic impactor, and there's still unknown consequences if you, either from the secondary or from, or if you don't push it enough with the kinetic impactors. The best way, technically, to defend the planet is to go with the nuclear device, and I think that's what you have to recommend. And I think you can justify it, and if there's political fallout, that's why that's why you're the leader.
That's precisely the issue to debate, because you are correct. The kinetic impactors have a great amount of uncertainty regarding their effectiveness and how much they move and what happens to the secondary.
And you have to hit it 3 times, or 2 to 3 times.
You have to hit them multiple times, so there's great uncertainty. Oh, okay. Yes, Dave.
Yeah, I'm sorry, I'm going to return to about 8 questions ago to Mark's statement about a tsunami being able to cross the Pacific, even perhaps hit both Japan and North America. This was exactly the kind of scenario we had our workshop for, and we were unanimous that that can't happen. That is, if you mean a 1-meter tsunami that's just as like a storm surge, yes, but not a highly destructive one of that range. Now, Mark is much more of an expert than I am, but I'm just saying that was what our workshop concluded.
We did. That was not unanimous.
Stand up, Mark.
Okay, I would like to clarify that was not unanimous. Vasily and I were dissenters from that consensus, and the reason dissenters is we did not model that. There were certain things we did not model, and now we have, and I presented it yesterday. You do get strong coupling, and I invite my colleagues to sort this out and to attempt to reproduce what we have done or to show what we did wrong. But you do get strong coupling from a surface impact, but it's not the displacement of the formation and collapse of the crater or the ejecta from the crater. I didn't even model that. It is the air blast and rarefaction moving at very high speed across the surface. That couples to the tsunami. You do get meter scale tsunami that then can focus up into very large tsunami. We did not model that last summer.
Top? All right.
I would like to urge the discussion to be focused on the topic at hand. I understand the issues page, and I'd like to echo, I agree, that the logical technical approach is to use the nuclear explosive device first. The other issue, just to address your simultaneous aspect, we don't know the effects. If you were successful in hitting the primary with the first kinetic impactor, first of all, we don't know the impact that would have on the success of the nuclear device, But certainly the follow-on kinetic impactors would, in all likelihood, be deficient in their ability to target the main body at that point. Even at 5-day intervals, there's going to be a lot of debris in the area that could confuse those. But the point is that we've got the ability with the device that we have there now, highest probability of success. You have multiple fallbacks in case that doesn't work. And again, I think the issue of using the nuclear option as a last resort was still predicated on the initial reluctance to actually launch a nuclear device. That has been overcome at this point. And I think once that has been overcome, the use of that, the technical viability and the use of the nuclear explosive device is the right way that you should move forward.
So the question to be considered here is the controversy over launching the nuclear device, or is the controversy over the use of the nuclear device at the asteroid? And that's the question that I wanted to raise here. Gerhard had a question.
Yeah, just had a question to get the full picture on the options available. I believe it was also recommended and accepted to launch, just in case, another 1 or 2 spacecraft, which should also have a nuclear device, just in case something goes wrong. This was recommended and accepted. It could only be a flyby mission, I understand. So what happened to those? Are those ready to launch? We should do that now. Just in case.
I think we have there are more kinetic impactors available for launch, and two more kinetic impactors available for launch, but I'm not sure about more nuclear devices. I don't believe we had that in our plans.
We had
2 more nuclear devices in our plans.
Yeah,
so
okay.
yes, they're available
so
for launch.
those should, I guess, be launched now just in case.
The launch opportunities are fewer at this point, but there is one more launch opportunity for a fast flyby. So that we will, if necessary, we'll get to that in the next inject. But I don't know what this depends on what you all decide,
there's
frankly.
Time enough, but I think this should be done more or less now, because whether they will be used or not can be decided later. But they should be launched to be ready on time to get there, if needed.
The launch occurs after this inject, so it hasn't happened yet. Joe.
All right, I'm really uncomfortable with the discussion for a very specific reason. We knew when we promised that we launched the nuclear devices, we told people we would not use them until the last resort.
Yes.
It had nothing to do with launching them. It had to do with the use, as far as I was concerned, but it doesn't matter. We basically made a promise to the world we would not use them except as a last resort. I understand completely the physics of the problem. Basically, we're deciding to lie and break our promise. I can't go along with that.
So we may, I don't know, the world leaders may have to vote on this eventually. Oh, we have yes, here.
But I think we have another problem. If we don't use it, the asteroid will go closer to the Earth. That means they're ready for using nuclear device will get closer to the Earth. Is it okay?
No, I don't believe that's correct. Yeah.
Okay, but we will leave the ready for using nuclear device somewhere in space. And what's happened with the previous rendezvous mission that is destroyed, or where is it? Okay, so we are okay about it.
We're okay about it. It was a SEP, spacecraft solar electric propulsion, and it lost attitude control, which means you could not point its thrusters. So it cannot reach the asteroid because it can't be controlled. However, we can still communicate with it. So it's just that it can't go where we want it to go.
Can it reach the Earth?
Ed has a comment up here, and then we'll get to Siegfried.
There is a difference from the original scenario plan, which was for launching of 2 rendezvous spacecraft with 2 nuclear deflectors. And since we've had a failure with one, you no longer have, you've taken a lot of options off the table, like doing one, having multiple chances afterwards and so on. So it's not quite exactly the same as saying you promised one thing and you're not delivering it, because there is a difference. No, there is a difference. There is a difference because you're, I maintain there is a huge difference between having 2 of these and having 1.
Okay. Timo has the mic, and you can cut this off whenever you like.
So
Timo.
when we're talking about using nuclear device as a last resort, Mark just mentioned modeling, and that reminded me of that we don't rely on testing here for about 30 years on this timeline, and everything depends on the model of how these devices age and so on. And so we're not quite so certain. It's scary enough for us on Earth to rely on that they're working, but is it enough hope in space that they are still working after 30, 40
We have
years?
some among the audience who could comment on the reliability, but we're assuming that they're very reliable. That's our assumption.
To Joe's point about the breaking of a promise, there are two things we have to keep in mind. One is that the two Rendezvous spacecraft, one of the Rendezvous spacecraft already had a mechanical failure that disabled it, which means that the current Rendezvous spacecraft, which is still operational, may be on borrowed time. We have no idea how long that hastily constructed spacecraft will stay alive. Also, the kinetic impactors may create a dangerous environment that would disable the Rendezvous spacecraft. So, by keeping our promise, we may lose the last resort option entirely. And that has to be considered. That must be part of the calculus. This cannot be done on principle. The promise breaking is of secondary importance to the technical realities of the situation.
Okay, I would like to suggest that we recall at the outset that Japan reluctantly agreed to put the nuclear device on because of the risk of millions upon millions of people being killed by a direct impact in the vicinity of Tokyo. The chances that there will be such failures of the kinetic impactors that they aren't moved out into the ocean, where I submit that the danger of tsunami that has 3 years of predicted 3 years in advance, and the danger of a super Tunguska landing somewhere to the west, that these are just very minor dangers to face and do not justify, would not have justified even the launching of the nuclear device. And so I think that Joe's point really ought to be taken very seriously, that it's a complete change of perspective to say, oh, we physicists, the most likely thing we can do is blow it up the way we promised we wouldn't, except as last resort. And the remaining danger, it's not, if they fail, okay, it doesn't go off the Earth, but it lands in the middle of the Pacific Ocean with 3 years warning of a minor, possibly major tsunami.
Steve.
May I?
Yeah, I echo with what Clark said. There is the fact, I think, that other than some fringe scientists, the tsunami is not a serious risk. There is the question, can you guarantee that if you put the asteroid on a near-miss trajectory, that it will not return to impact the Earth in 6, 8, or 10 years later? In that scenario, you don't have any time to respond because all of your assets are somehow spent. So putting it in the ocean is a permanent solution to the problem, not necessarily a temporary solution.
In fact, preferable, perhaps, to pushing it off of the Earth, because then there's a chance it will go through a keyhole.
Just kidding, Mark.
Thank you. I love it. I love it. This scenario could go on and on if that is the case.
Yeah.
Are there any other questions? Oh, top, yes.
Yeah, there's just one thing I think we're forgetting in all this discussion. In this scenario right now, we have an armed nuclear weapon headed straight for Tokyo. And I think getting that thing out of the picture would be very popular with a lot of people. So I think while we promised we wouldn't use it, right now we've got it headed in a place that perhaps we might be excused for setting it off.
We are relying on the fact that we can maneuver that away from that trajectory. And we can, as long as the spacecraft survives. Yes, that's true. It's an excellent point. Yeah, that's right. More comments. David.
Going back to Joe's comment, I agree. We made that promise. But I also think that we, in this exercise at least, need to think like politicians too. And you wouldn't have to break your promise. Well, it's just for the exercise. But I think you could explain to the people that, we did make that promise. That is correct. But we have now had more time to study this. Things have changed. and we have now learned, or we now feel like this is the best option. I don't think if you give people...
What is the best option?
To use the nuclear device. I think if you explain to people that the options are, we may still have this thing hit the Earth even if it's in the ocean, or we have one thing that is a very high reliability to make it miss the Earth completely. I think you can say that after we've studied this more, after we've learned more about the technical aspects of the problem, yes, we said we'd use it as a last resort, but now we feel like this is by far the best option, and you can... I
think we should, yes.
No, but I think the option of...
Siegfried has a comment. He's had his hands up for a while. Siegfried.
Sorry. I just wanted to remind people that while we are sort of aware that the kinetic impactor has uncertainties in its working, nuclear devices probably have uncertainties too, right? Do we know how much they are?
The uncertainty in
when you
execution of the...
Exactly. So the uncertainty in delta V that you get from the nuclear explosion.
If the device works, it will provide more than enough delta V. So that's not in question. It's the question of whether the device works then.
Oh yes, but that goes into Steve's argument. Even if the more you push for a given uncertainty, the more uncertain the outcome is if you don't know where it ends up. So if there are keyholes in the vicinity, the capability of pushing it more doesn't necessarily mean it's safer if you don't know where you put it in the end.
Okay, let me just say, this really could go on forever, it's clear to me. And I think what the leaders would do at this point is say, okay, guys, we want you to go off and come back with specific recommendations. Number one is what is the two approaches. Number one, if we don't use the nukes, what is the best solution that gets the job done? And secondly, if we do choose to use the nukes, when do we do that and under what circumstances? For example, there are two options for that. You could use the one you got there now, or you could arm these two kinetic impactors or two other spacecraft that are going out and do it in a flyby mode. So I think that maybe what we might want to do really is to go back to our groups again and have those groups come in with some specific recommendations that the leaders can then assess the politics of it and make a decision, and then those leaders are going to be responsible for whatever those decisions are. And you had a comment?
Yeah, I don't think any reasonable leader would make this choice. You would have a referendum. You would lay out the options and you would give the people the choice. And then the leaders would then have to choose whether or not they want to do what the people
That's good.
selected.
Well, why don't you do that, come back with that recommendation from your group then. So if you don't mind, if you would go off and maybe for, is that reasonable, 15, 20 minutes?
Bill, can I make one comment up here?
Yeah, sure.
One thing we haven't discussed is the whole economic situation again. I think there's going to be a sense of urgency here because at this point, when it's essentially as things are, there's 100% certainty that if nothing changes, you've lost the world's third largest economy. Okay, yep. So at this point, if you think about it, there's probably zero investment going on for capital expenditures in Japan, in the world's third largest economy. It is probably impossible to sell long-term bonds. The government of Japan may be bankrupt at this point, right? Because all of their outstanding debts are probably being called in, right? I think there's going to be an enormous sense of urgency here because I can't even imagine what this does to the world economy, let alone socially here within this country, right? If you are no longer planning for anything longer than about 3 or 4 years, what does that do to a country? I don't even know.
That's true. You're on the world leader group, right?
Yeah. So
why don't you,
so there's a sense of urgency that I don't think scientifically we don't think about, but you really do have to consider this from here's what's going on in the world.
Okay, so I think maybe a half an hour of discussion so you guys can, the world leaders can sit and kind of converge on a solution to this thing, or it might be a good way to go. And again, it'd be nice to have the mission design people look at what the options are, specifically those cases where you respect the promise that was made that use this as a last resort, and also what the implications might be of doing that. So, reasonable? Half 30 minutes, right? Makes sense? Okay, so you may vanish and come back. Go to the places where you were at your last meeting. Ah, here it's one. I know that's one of the groups. Okay, so no kidding. I think it's, one of the things it's interesting, is that somebody mentioned this during the break, and I think it's, even though we are all coming from more or less one side of the house, we're all more or less technical people and not really politicians and so forth. It's interesting to see the discussions and how that's all going, and it's very representative of what we might see if this were actually to occur. So again, for anybody watching online, this is just an exercise. Just want to emphasize that. And for all of you, I want you to understand this is really fictitious here, so it's good we're taking it seriously, but up to a point, I think. Okay, so and given that, why don't we just go ahead and get report backs from these various groups? Group 1. Okay.
Thank you. Ladies and gentlemen, dear esteemed world leaders, the International Asteroid Warning Network has convened, and our recommendations are as follows. We suggest that we let the asteroid hit the ocean to ensure it never becomes a hazard again. Our suggestion is to hit the primary once with a kinematic impactor. We need to time it well enough to collapse the system and ensure that it becomes more closely bound. From observing the first impact, we will be able to measure the delta V change and see the ejecta, and from that, we'll be able to determine the beta. We expect that the beta will be greater than 1, and 1 impact should be enough. After the first kinematic impactor, we can see whether more impactors are needed. We propose this as a much cleaner option. Afterwards, we will need to monitor the debris falling on the Earth using ground-based and airborne campaigns, as well as radar. However, if it is chosen that we should deflect it from the Earth, there is a chance that it will come back and hit us again. In this case, it is crucial that we keep the observer spacecraft orbiting to ensure that we know the orbit well enough. We have concerns about the lifespan of the orbiting spacecraft, given the first one has already failed. Hence why we're suggesting the first option. As a very last resort, we do recommend using the nuclear device if all else fails. Once we are absolutely certain that the asteroid no longer poses a risk, we recommend diverting the nuclear spacecraft and safely disposing of the nuclear device. We could also aim to repair or somehow fix the damaged device and try to divert it on a science mission somewhere else. Thank you.
Okay, the leaders have any questions, or you want to hold off for a bit?
Do we have questions? Thank you. No, that was very clear.
Okay, group 2.
I'm sorry, one comment for the first group?
I guess the comment would be, although we might understand about permanent disposal of the remaining asteroid system in the ocean, there would still be tsunami. There's still danger there to people and property by doing that method. Correct? Is that correct? That's the question.
Well, the impact effects group would be the ones to answer that. And I have to say that the impact effects group concurs with our very wise colleagues in the planetary astronomy observing community. Our very wise and inadequately funded colleagues in the planetary observing community. So the key question here is balancing risks and trading risks. And in a certain sense, statistically, it probably doesn't make a lot of difference whether you deflect it on the Earth, off the Earth, and accept the risk of a keyhole and essentially an unavoidable subsequent impact. And yet, the consequences of that are very severe. On the other hand, the consequences of a tsunami may be imperfectly understood, but there is a consensus that this would create a kind of a tsunami hazard that nations in the Pacific Rim are used to dealing with. Maybe something far less than that, but certainly not these kind of the 2011 tsunami that's a 1,000-year event. This would be a modest tsunami, if that. So you have to balance this, the keyhole with where you have too little time to respond and a potentially catastrophic outcome at the probability of 10 to the minus 4, maybe 10 to the minus 5, because the astrodynamics community hasn't had the funding and opportunity to map the keyholes yet. You only need one, or perhaps better, 2 successful kinetic impactors out of 5. If you time the first one to reduce the orbital energy, as was mentioned before, you can be assured that the second one will not disrupt, and so that's the target. You then have 3 spares, essentially, and you still have the last resort. If all 5 fails, the nuclear device is still on hand as a last resort, because it was never flown as a first resort because of political considerations in Japan. There's one other thing that was posed by the impact effects community, and there will be a plume extending hundreds of kilometers into space that will last upwards of 10 minutes, and then it will fall back to Earth in a ballistic trajectory. And the presumption that needs more study is that space assets will have 3 years in order to maneuver to be elsewhere and not fly through the plume. But this is something that certainly needs more study. The nuke itself, once you have successfully deflected it to the ocean, can be detonated and disposed of in a safe location.
Okay, comments?
Do we have any questions?
Okay, let's thank group 2.
Thank you very much.
Okay, group 3. Oh yeah, you're up. Oh, you're 3 and 4. Okay, good.
Okay, so since we are a mission design and deflection, so our goal is not to take a hit, but to actually deflect and to keep us all safe. So we are now in June of 2023. What my zeroth recommendation is that we do launch the 2 kinetic impactors that are already on the ground. They have been completed. I think we recommend you should consider arming them, and they should be launched, potentially arriving at the asteroid in March 2024. So plenty of time. This would be a valuable backup. We also recommend that you continue building kinetic impactors, as many as you can, because we have now production line going. They're not as expensive anymore. And these would be last-ditch efforts in 2026. If it comes to that, they better be armed. So that is our definitely zero-order recommendation. So with respect to 2 options, whether we go nuclear with a nuclear device that is already on the spacecraft that it's orbiting, or we wait for the kinetic impactors, again, from the engineering perspective, the cleanest and most effective solution that we recommend is detonating the nuclear device. It is already there, and that one is going to, kind of with one hit, you're going to deflect the primary and destroy the secondary. We believe that we have capabilities. We have high heritage, it has very few moving parts, and our simulations have very high fidelity. Minus thing is, yes, nuclear device has not been tested in space. However, we do have that second rendezvous spacecraft out there with a nuclear device, and we can do controlled detonation in space to test it. So that would be with respect to nuclear device. If you do not go with our first recommendation with the nuclear, in that case we are going to just proceed with taking a hit from 5 kinetic impactors that are on their way, and the first one is arriving in February of 2024. So in this case, so the advantages of this, obviously we have precedent for that. There was a deep impact on Comet Tuttle, and we also hit the Lacrosse spacecraft into the moon. So we definitely have done this in the past. The minus thing is obviously you do need 5 kinetic impactors, so it's less effective than the nuclear option, and on all 5 devices need to work in order to really deflect the asteroid from the surface. So that is That is our report.
Thank you very much. So what is the minimum number of kinetic impactors required to deflect into the ocean? Obviously, the 5 are required to miss the planet completely. What is the minimum number to miss Japan, to minimize the tsunami damage and get into deep ocean?
So the minimum amount is 2 to 3, right?
One?
Just one is enough? Okay.
Okay,
So,
thank you.
So it depends how far you want to go.
Okay, any further questions? Yes.
Yes, to make sure that we can take all the decisions in time, you advise to prepare for more kinetic impactors. Do you advise also to prepare for more nuclear devices to be sent?
Yes, if it comes to that, so if we do need a 2026 launch, that means a lot of options have failed, and in that case it's serious, and we definitely need to have armed it with nuclear device, and then we are going to destroy and not to deflect.
Would you have a number?
So as many as we can build. So the production line, as I said, production line are in place. It's getting cheaper to produce this. We are getting more effective. So at minimum 2, but preferably more than that. So as much as we can afford.
Thank you.
Comment, question. Yeah, I'd like to ask you to comment on the recommendation earlier about dumping it in the ocean. And what is the reliability of accomplishing that? I mean, we've heard reported that the danger from the tsunami is that's going to happen 3 years later is minimal, and it was recommended by an earlier group, that 1 or 2 kinetic impactors would move it far enough to minimize the tsunami damage. So what would be the reliability of that? In other words, what are the chances that if we were to decide to do that we would fail in that mission?
Well, all this is very, we still have so many opportunities to really avoid even having that kind of discussion. So if we can deflect the asteroid to completely miss the Earth, we should go for that.
No, that's your recommendation.
Yeah,
I'm asking about the reliability of the earlier recommendation.
So
what are the chances of that failing, of 2 kinetic impactors failing?
So that you really have, well, in that case, you would have 2026 option that you go nuclear. So in that case, something would succeed. So
I know, but the question is, what is the reliability of the 2 kinetic impactors failing? I understand there's downstream.
There are, but we have 5 of them on the way, so I'm not sure. You are
That you
assuming
cannot-
3 of them failing and only 2 of them hitting?
4 of them failing.
4 of them failing and a single one. So single one, as Brent already mentioned, single one is sufficient to deflect it from the coast of.
What are the chances of us not being able to do that?
I have a comment. Because we have 5 of these spacecraft coming in and they all appear healthy at the moment, in order for the single kinetic impactor move to the ocean to fail, all 5 of those spacecraft would have to fail in some way.
And what are the chances of that?
The chances of that are low. I don't have a number, but it's low, right? I mean, it's very small. I'd say, if you want to put a number on, say it's a 5% chance. I'm sorry? Well, no, so they're sub-thrusting. Are they thrusting all the way down in?
Yeah, let me clarify. Yes, you stop the SEP thrusting on approach, and then the final approach has to be done with chemical thrusters. So if they die, the chance is that if they die, let's say 1 day out, the chances that they are not going to hit. You need active control up to the final impact.
Right. So, again, just to clarify, we have 5 spacecraft, so that improves reliability. They were all constructed hastily in a crisis. That lowers reliability. So those 2 effects are in play, and there is a chance of failure. But if you only need one of them to work, the chances are reasonable that at least one of them will work.
And that is not a final. That is not our final attempt, because we have 2020. We have 2 more launched, and then we have potentially at least several more on its way in 2026. So. And we had at that point we would try a nuclear option.
So you've we've been now just given this new potential risk that after we exercise the nuclear option where we've destroyed the secondary and we've deflected from the Earth the primary, that we could have a risk years later due to entry into a keyhole, which none of us world leaders understand what the whole keyhole thing is. So you'll have to go back and explain that to us. But assuming that there is we'll call that a secondary risk after the nuclear option, could we use the remaining kinetic impactors to deflect the primary even further to get rid of this future keyhole risk?
That's possible. And just to clarify for the world leaders what the keyhole risk is, when the asteroid passes nearby the Earth's gravity will bend the trajectory of the asteroid around the sun and place it onto a different orbit around the sun than it was before it came close to the Earth. And because that change in its orbit happened while it was close to the Earth, there's a chance that it could be locked on a return trajectory such that its new path around the sun will bring it back to encounter the Earth some number of years later. That's the possibility. Now, once that's happened, a greater amount of energy is required to deflect the asteroid than was required before the keyhole passage in some cases. But that doesn't mean that it couldn't be deflected again. The probability is low.
But would it be wise, since we have kinetic impactors still en route, to try to deflect the primary even further than what you would have hopefully successfully done with the nuclear?
In practice, we would study the keyholes in advance, and so we could quantify the probability, and we could also quantify the utility of adding extra momentum to the asteroid, as you suggest. So I would say what you're proposing is viable, but would require further analysis.
I'd just like to add to that the most likely keyhole would be in a orbital period that's very similar to what we have now, and so 10 years would be the most likely time period before the next hazard, and I would suggest that that's beyond the horizon of this particular discussion. So there might be another 10 years we would have another problem. Next conference.
Do we have...
The intrinsic probability of chancing into another keyhole is approximately 10 to the minus 5. That's average over all asteroids and all everything. We're talking about a very, very small probability of landing in the second keyhole.
Okay. Ed?
So if the chance of a keyhole is very small, I'm not sure about 10 to the minus 5, but it's quite small, right? I might suggest that the suggestion of dumping it into the ocean and risking a tsunami is far riskier than taking the risk of a keyhole. Far riskier. And I might also say that the public may feel that if we do something and we dump it in the ocean and yet still people die, which is possible, that it might be considered a failure, even if it's far less of a loss than a direct hit.
Okay, let's press on if we could. Let's see. Let's thank Group 3 and 4, by the way. They did a nice job. Okay, Group 5, experts.
Thanks, Bill. Thank you, leaders, for having this opportunity to speak with you. Based on our discussions, we looked at the options to deflect completely off the Earth's surface. So we'll exclude the discussion that's already been talked about of dumping it in the ocean. We felt that both options, and the options are to either use the kinetic impactors in succession first and the nuclear explosive device as a secondary deflection opportunity is one option, and then to use the NED first is the other, to deflect the primary and disrupt the secondary as the approach. We thought both of these options are technically feasible. The third option that was discussed in our group of actually targeting the secondary first with one of the kinetic impactors, the initial kinetic impactor, we did not think that this was a viable option, and it was not discussed by the previous group because of the risk of disruption of the secondary and the effect that might have on subsequent kinetic impactors, as well as the rendezvous spacecraft with the NED on board. Additionally, we agree that the future option of the additional kinetic impactors and the flyby nuclear explosive device should be launched and as backups, despite whatever decision is made. But in a 9-to-1 decision among the decision to act members, the NED as the primary option to use that first was the decision in that group. So we'd like to express to you that that was, again, based on the discussion here, probability of deflecting the asteroid and taking care of the secondary. The risk of going through a keyhole, as you've just heard, is quite small. Highest probability that the asteroid would be put on a trajectory that would never be an issue with the Earth for the foreseeable future. So that is our recommendation from the group.
Thank you very much. That's very clear, and we appreciate the background on your decision process. Do we have any questions from our world leaders? Okay, thank you very much.
Okay, the communications and public communication stuff. Here you go.
Thank you. Good morning, honored leaders. This recommendation is from the Crisis Communications team. I would like to take a minute just to review a few things for you. The Japanese economy is broken. The World Bank is supporting the Japanese government. Immigration is depleting. Industry is leaving Japan. The people that remain are not able to find jobs. The status of the evacuation plans, public comment was very successful. These plans were built internationally as well as nationally and received in-depth public cooperation and support at the local, the town, and the prefecture level. This was very successful. There is an increasing confidence in the ability by the people that Japan can manage an evacuation in a good and timely manner. However, aid and comfort from other nations is required now because the people are suffering, and there are emergencies on every day. The hurricane last summer wreaked havoc on the North Island, and things are not recovering, so we need more help. This may be rocket science, but it's not the Kobayashi Maru, people. Right? Can we make a decision here? Crisis communication team speaking. We've been discussing this since launch, and there's no consensus. Therefore, based on all the knowledge at hand, to hand today, including a clear articulation of all the probabilities, pro and con, let us stop waving our hands at technological probabilities that you only analyze through modeling, not actual real-world events. We understand that we are setting a moral precedent, both with how this decision is being made and in the use of the nuclear device. However, the people of Japan and of the world are terrified, and we must urge you to take their needs into consideration. We, the Crisis Communication team, have voted by simple majority, and we urge you to do the same thing. If you haven't reached consensus by now, we think you must vote by simple majority. We support the detonation of a nuclear device, but we do it over the strong dissension of our dissenters, and we are very, very well aware of that. Thank you for your time.
Thank you. That's a very powerful set of recommendations. All right.
I didn't understand if what you're supporting is the early or last resort detonation of a nuclear device.
That was the key of the disagreement among the team between early and last. So a simple majority carried for early detonation.
Thank you. Any other questions? All right. Per
Thank
our
you.
discussion yesterday, we acknowledged the need for other nations not in the impact hazard ellipse to act to affirm their own status as not being in the ellipse, and also to provide aid and comfort to those who are. We hope that you are supporting us in forming plans and helping us to communicate to our people that the actions that they can take to be of assistance. I believe there is a tremendous enthusiasm to participate, to donate to do whatever we can to help, because I think many of us would be feeling pretty useless.
It's been absolutely overwhelmingly heartwarming to see the response of third world nations, of all the nations on the Pacific Rim, and all the nations of the world. However, sending 4 years prior shipments of water, which won't last. So we've had to do a little clarification of things that are needed now. Immigration, the ability to immigrate, the two centers for Japanese people, not in Japan, I believe, or Australia and the United States are two key worlds. Both of these have kept their borders open. Other nations have not been quite so, but we are encouraging people who, if they have family and have jobs to go to, that they consider it. However, we also encourage them to be able to return.
Yes, thank you.
Thank you.
Thank you. Good job. Let's thank that group, please. Okay, disaster planning. I see somebody's really dressed the part here. So
let me start by part one. Nobody dies. We're all prepared. So, we want to emphasize that there are plans all along the corridor to deal with any of the contingencies, whether none of these things work, you disrupt things, so forth, you dump it in the ocean, tsunamis. There are plans for all these things. However, right now, there is suffering, there is damage right now. Every day, every month that goes by, there is damage happening. So, from our perspective, the simplest solution is we have a way to eliminate that uncertainty right now. We would suggest using that. If it works, none of the plans need to be put into effect, and we're done with this. If it doesn't work, we have other possibilities, and we're prepared for those other possibilities. If the decision is to not use the nuclear device, we would like to see that taken out of the equation that we're dealing with, have it be disposed of properly. Having to deal with essentially the equivalent of a dirty bomb exercise along with the impact is complicating matters. People are worried about the radioactive fallout and so forth, which is just adding and compounding the problem. So my understanding is that the quickest and easiest way to get rid of that is to set it off, and then we don't have a nuke anymore. But if the decision is not to do that, please find a way to remove it from the equation of things we have to deal with. Thank you.
Thank you. Those plans are in place. We do have some questions for you with regard to the tsunami. We want to know what is going on in terms of emergency preparedness, if it is an impact into the Pacific and at Japan, at Guam, at other Pacific islands that may be affected. We know some of them are under stress with the potential for sea level rise, that there's not a lot of height to some of those islands. We're concerned also about the effects on the west coast of North and South America. Could you please comment on that?
Well, we're relying on the impact effects people to be doing the modeling for exactly where the tsunami might be focused to cause some problems. We expect from the preliminary studies that those will be very discrete locations. If we know where it's going to hit in 2024, we'll have 3 years to prepare for it. Again, there should be no reason why definitely any person will be affected, and even major infrastructure should be able to deal with that. Unless the modeling shows something totally unexpected, we know the existing plans with minor modification should work.
Okay, thank you. Any further questions from our world leaders? Thank you very much.
Good job. Okay, well, I think it's we've had some good presentations. Do you guys want to give us your thoughts?
All right. Thank you very much. Oh, thank you. As world leaders, we have had a lot of discussion. You've seen here on stage and in your own breakout sessions and on the internet, you've seen emotions run high, and our debate and our discussion of this drill has become quite passionate. And I think that's very important. I think that it's important that we play to win when we do these drills. As I've been told by colleagues at NASA who do drills for human spaceflight, they've all said, please play this to win. And as echoes the advice of my Budo martial arts teachers when I was a child, you train the way you're going to fight. Otherwise, you fight the way you train. And so I'm really pleased to see everyone taking this so seriously and being so passionate about it. The advice of the communications team to not seek consensus, to go with majority votes is well taken. Fortunately, we have already achieved consensus. We have decided that since Japan is the focus of this disaster, they are bearing the brunt of the hazard both before, economically, and in terms of preparations, and during the threatened impact, that we voted unanimously to support the decisions of the government of Japan. And so I now cede the mic to our President Yoshikawa.
Okay, at first, as a representative of Japan, I thank to your discussion to save Tokyo and Japan. Okay, and yes, this is a very serious problem. We have just 4 years before the collision, and the target is Tokyo, the very big city. So, as a Japan, we do want to avoid the collision, of course. And the method is, we think this is a very emergency case. So we think that any method is okay, because there are no method that is 100% reliable, okay? Kinetic impactor is reliable, but not 100%. So we would like to launch as many as spacecraft to deflect the asteroid. So yes, the problem is nuclear device, nuclear weapon. And in generally speaking, Japan is against to the nuclear weapon, of course. But in this situation, I mean, in this exercise, I think nuclear device is one of the options to avoid the collision. So when we use the nuclear device, first or later, I think this depends on the technical matter. I think the first what we must do first is most probable method that can avoid the collision, and then next one and next one. I think that is a best way. Okay. So anyway, thank you very much for your very enthusiastic and profound discussions.
So again, from the leadership group, their options are to use the nuke that's there now, or to wait and use the kinetic impactors. Is there a preference for that? Which way would you like to make that work? Should we use the nuclear device that's in orbit now, or should we use the kinetic impactors first?
Yes. Yes. Your question is which is first?
Which would be first?
Yes. Kinetic impactor and nuclear device, and which is first? Yes. Yes. This depends on which is better, which is a better method to deflect the asteroid. Yes. So it depends on the purely technical issues. So
okay.
Yes.
Okay, good. Okay, I guess maybe from the same page group, the Space Mission Planning Group. So Brent, it sounds like there's a bit of an option. Yes. So we can pick an option here.
So some comments on the probability of success. The nuclear device itself is intrinsically high heritage and constructed to exquisite levels to exquisite construction standards. However, this would be its first, in this scenario, the way that we've laid it out, it would be its first use in deep space after a heliocentric cruise. The nuclear physics are fairly well understood. Kinetic impactor physics are also well understood, so they're roughly equal there. However, the nuclear device is already in place, and it's on a rendezvous spacecraft that's pacing the asteroid in its orbit, very low relative velocity. The task of maneuvering a spacecraft in the vicinity of an asteroid is also high heritage. So it's a relatively simple system with few moving parts. By contrast, the kinetic impactors are coming in at hypervelocity against a much smaller target than we've ever struck in deep space. And so to strike such a small asteroid at such high velocities with kinetic impactors is utterly unprecedented. So from a guidance, navigation, control standpoint, and in view of all the other factors, I'm forced to conclude that detonating the nuclear device is the highest probability of success for this mission.
May I add to that? These kinetic impactors are coming in at 8 kilometers per second. So it's actually, they are relatively slow compared to other kinetic impactors missions that we've had, these particular ones.
Well, the only other one was Deep Impact, right, at 10 kilometers per second against a 5 kilometer sized target. So 10 kilometers per second versus a 5,000 meter bullseye, 8 kilometers per second versus a 270 meter bullseye. It's a much harder guidance problem.
One other point that we need to realize is that we don't have to decide immediately, but we do need to decide by, as the asteroid comes near perihelion. Perihelion is the time to deflect, whether it be nuclear or the kinetic impactors. They're aimed to arrive around the same time. So January is still a few months away, is 6 months away or so.
It is, but for purposes of the scenario, they're making the choice now.
That's right. That's right.
Yeah. So in summary, to answer your specific question directly, the method with the highest probability of success is to use the nuclear device that is already on station.
Okay, so would an acceptable approach then be to use to attempt to use the nuclear device, and if it does not work, you've got the kinetic impactors that are coming in, and you could always that would be a backup.
No, I have an additional question from what was just said. Hi, Brent. I think I heard you say that we would do either the kinetic impactors or the nuclear device at perihelion, but our discussion has included doing it now. It would work now. It might be more efficient at perihelion, but it would work now?
No. In order for the orbital mechanics of the asteroid deflection to play out correctly, you have to wait a few months before you detonate the device so that the detonation occurs near the asteroid's perihelion, which is a small matter. I mean, the decision on what to do can be made now, which is what we're doing in the scenario, but the actual moment in time when the detonation occurs is a few months hence, it's just a small detail.
I would think that the nuclear deflection could be done now with slightly reduced efficiency. It would still work. It is not for the kinetic impactors. You don't get as much choice because they're on their way. They have a certain impact point. But for the nuclear, you can do it whenever you want.
Right, there is some flexibility. We haven't modeled that, but sure, you could do a reduced performance deflection. It's still enough to get it off the Earth.
Wait. Get the mic, please.
Yes, you want to be near perihelion, but once you have rendezvoused with the object, you are not constrained as you are with a kinetic impactor to 1 day or something. My advice would be hit the nuke a month or two before the kinetic impactor point, and then you can use the concept of virtual impactors where you aim the kinetic impactors to the point in space where any debris remaining that is on an impact trajectory would be, and you hit it. If there's nothing there, the job's done.
Okay. Is that an acceptable solution?
I do have one question.
Yes.
One of the things that I would suggest is that between now and the time that we actually have to act, which is several months from now, you refine the probabilities, because my feeling is that the difference between the two options is 99% versus 98%. And I'm not positive that that's outside our realm of certainty. So I think both are very high probability deflection options, especially because you only need one impactor to get it out of Tokyo. You need more to get it off the Earth, but you may only need 2 or 3 if the beta is higher than 1. We're making the assumption beta is 1. So my suggestion would be that you do more study of the probabilities, and I don't actually think there's much difference in the probabilities of success for the two options.
Except for the fact that you have a spacecraft there now, and therefore that is intrinsically boosting the probability of success compared to spacecraft not yet arrived.
That's certainly true, but it's still not completely going to be the case if you're going to wait to detonate the nuke until the impactors or until perihelion anyway. So you're still taking the chance that something goes wrong between now and the end.
Okay, but I think we've got technical testimony that says that we, in fact, could detonate the nuke now and do the job. And again, I guess the question would be, and I think Ed Liu's comment relative to the economy, your comment about the economy and the fact that it's suffering, I would imagine there's some pressure put on the leadership to get something done and get this risk over with. It sounds like we have an option to do that now. Should we proceed with the nuclear as the first option and kinetic impactors as backup? Okay, agreed among the leaders? Okay, so I think we've got an agreement on that. And if Professor Chodas, if you could let us know, do you want to let us know now or you want to let us know later?
I suggest we have a break. We have our slides ready when we
good.
reconvene after a break.
Okay, sounds good. Break time, guys. Ready to come up, but why don't you I'll just give a quick intro here if you want. Okay, are we ready? It looks like. Okay, so I thought what we would do is Professor Chodas here would like to kind of give us a summary of what all these decisions led to, and so are you ready?
I'm ready. This has been an adventure from our point of view for the whole week, and it's been hard to keep up with all of the decisions, and we've certainly introduced some controversial topics, and that was intentional because we wanted to make a realistic scenario that had many difficult decisions, so that was partly intentional. We've prepared a few endings, but it's been hard to prepare all of the possible endings as we went along. So what I will do, I think in fairness, is to show 2 endings. And 2 that we have prepared. And I will start with, it is definitely a cheap way out. oops, slideshow, here we go. Here is ending number 1. The ending number 1 is that the group decided to use the nuclear explosive device, detonate it near the asteroid, and I've listed the perihelion date, because that's the optimal time, basically it's February the 5th, as the time you could do this. But it's absolutely possible to perform this detonation because it is so effective. It can be done 2 months earlier. In fact, it could also be done 2 months later, if necessary, if the kinetic impactors perhaps failed or whatever. So this is a viable option, and it would successfully deflect the asteroid off of the Earth. This is the only information I would provide on this ending number 1, that the decision makers decided to deploy the nuclear device from the observer spacecraft and detonate it at a standoff distance of about 1 kilometer from both the primary and the secondary, and you could time that because you know the orbit of the secondary. The spacecraft itself would be stationed away from the detonation, perhaps behind the primary for its own protection, because we want it to continue along and observe the effect of the deflection. So this is a viable solution. The primary component would receive a large delta V from this explosion on the order of 1 centimeter per second or more, and that's clearly sufficient to move it away from its Earth impacting trajectory. So nominally we can say, 1,000 kilometers, it would miss the Earth by 1,000 kilometers on that date. The idea that it might go through a keyhole is possible but very unlikely, but it certainly needs to be investigated. But we would have an observer spacecraft flying along with the asteroid. It would be essentially chasing it, and we would know almost immediately what trajectory we're on. And in all likelihood, it would miss the keyhole, and we're safe for a century. Okay, so this would work. And by the way, the secondary component would be completely destroyed by this explosion. Okay, so this would solve the problem, but I understand it's controversial. And part of the rationale for the exercise was indeed to raise this idea that this option is on the table, but it's not well discussed. And the idea was to have this discussed more. I have to be perfectly honest that when I started this, I thought it would be impossible for kinetic impactors to deflect the asteroid to the east. Now, I had been saying that especially because this asteroid is in a large orbit, and as I explained earlier, the only way to deflect it east is to get in an even larger orbit and hit the asteroid from behind to boost its velocity, and that's not easy to do. In previous exercises, I've said that was impossible, but this exercise had 10 years of warning time, and that was sufficient that Stas, thank you very much Stas, found a trajectory that could deflect the asteroid to the east using a kinetic impactor. And therefore, I learned a lot from just going through this exercise. So I want to provide a second ending, which I had not originally planned on. So help me go to number 2. Escape, yes.
And just go over and get the other one.
It's
No, put it here.
over here.
Yeah.
It's B.
Yeah.
And is it here? Ending number 2, which I did not think was possible originally when I started this a year ago, is that indeed kinetic impactors could work. They could, in fact, in our scenario, 4 kinetic impactors deflect the, sorry for the bad English there, they deflect the asteroid off of the Earth. So this is what I would say on this alternate ending B. That the decision makers decided to forego the use of the nuclear explosive device and rely on the series of kinetic impactors to deflect the asteroid. Now, admittedly, there is risk in having a series of kinetic impactors hit the asteroid because each one is stirring up debris, each one is stirring up an unknown amount of delta V. There's some retargeting involved in following the primary as it moves, but this is certainly doable. And 5 days apart was the number we chose. Each kinetic deflection would add about 0.08 centimeters per second by our calculation to this asteroid. Now that's not large, but it is enough if you accumulate it with 4 of them and a beta of 1.5 to move the asteroid completely off the Earth. And I like a clean ending, and so this was the ending that we had suggested from the kinetic impactor point of view. So the rest is basically the same. Now, you might ask, what about the secondary? This acceleration is gentle enough that the moon would be dragged along with it. So we would get both objects off of the Earth. So this is actually a completely viable ending that I hadn't anticipated a year ago. And so I would put it out there as an equally valid ending. Now, so that pretty well terminates the exercise. I want to, Brent, if you can come up and Mark, my collaborators here have given yeoman's work here, if I can use that term, in helping me with the calculations, in doing the mission designs, the impact effects. And Lorian, is Lorian here? Lorian also has done a lot of work in helping with the impact effects, doing the casualty histograms and all of this sort of thing. So I've had a very talented team aiding me all along in these designs, and I appreciate it immensely. So thank you very much.
And of course, I think we need to thank Paul for his creativity here in doing this. So thank you very much again, Paul. Yes, go ahead.
I am amazed at the improvement in reliability from our exercise 2 years ago.
Yeah. Well, again, I think there are all kinds of things that we didn't discuss too much here, and reliability is certainly one. So again, I think the intent here was to kind of raise. This was structured so that we'd have some good discussion, which I think we will all agree we did have good discussions. And I think having the discussions in smaller groups was a really useful thing to do. And we wanted this to be realistic in a sense. One of the things we want to carry out of this kind of exercise is information to leaders of the kind of hard decisions they'll need to make and consider if something like this comes along. And we know that that is going to happen. And so we try to make these things realistic so that we represent that accurately. And I think you as members of the public and also technical specialists have done a nice job of expressing the kinds of things that the leaders will need to think about. And one thing that we'll be doing, of course, is to capture a lot of this material in our final report. And so we will want to, we're going to have a little exercise. I don't know, we've got 45 minutes. We potentially could do that, some of that now. But I'd like to just get your opinions about this exercise, its format. It's different than we've done before. It was uncertain, and so we fortunately have somebody who never sleeps that could actually adjust. And but what do you think? Is this something we should try again? Okay. I might mention before I go too far, it was suggested that we actually hold a vote to see what people would have in this group which choice would you have made if you were if this was the UN or someplace and you were going to make an estimate of which choice you would make relative to this particular scenario. Do you think we ought to? Yeah, that's right. Before you knew the answer, should have done that. That's true. Do you think we ought to have a vote or not? Okay. So how many thought that this was the right scenario for us to use in this case? Raise your hands. The one we chose, basically using the orbiting device first. Oh, no, I'm sorry. This is his chart, and I'll get rid of it. Okay, back to square one. Not square one exactly, but okay, there were two choices. One was to use the device that's there in orbiting and set that one off first, and then follow it up with the kinetic impactors if necessary. Thoughts on that one? Is that the right choice, or would you have agreed with that choice? Okay, and what would you, if you had preferred, would you like to use the kinetic impactors as the technique of choice? Okay, so it looks like it's roughly even. So, okay, I think that's, again, this is very, very instructive, and I think it may turn out that one of these days will actually, the choices will be limited. Namely, the only way you'll be able to move it effectively is to use a nuke. And I think we will need to understand how to express and how to explain that concept to people so they can really understand what the risks and uncertainties and the consequences of that are. So that's one of the challenges of our community, I think. And one of the things I think we heard earlier is don't say this is a weapon, it's a nuclear explosive, or something like that. Some other choice is one thing we'll need to use. Okay, so I think if you had any recommendations about how we should run this exercise differently, what are those? Okay, there's one. Here, give him the mic.
Who?
One recommendation I have is that you guys can announce some possibility as a fact. Otherwise, people is going to argue if it's possible or not. So if you guys present certain thing as a fact, I think that's going to eliminate some small discussion that we are trapped into.
I'm not sure I understand what you mean.
So, like a percentage. So the chance of having the deflection, I mean, the kinetic interceptor is 80%. You can just announce that as a fact. Because some people say, oh, it's more like 20%. Some people say, oh, no, it's more like
the chance of
95%.
failure.
Right.
And yeah,
So I think there's a broad spectrum of that.
Fair enough. That's a level of fidelity that is even deeper than we achieved here. Yes.
Yeah, we could do that, I think. Right?
Mm-hmm.
Yep.
Wait a minute, I object.
Yeah, take the mic.
How can you possibly give reliability numbers when we're talking about things that have never even been tested?
Yeah, well, yeah, so the whole scenario has never happened.
That's why we have to announce as a fact. Otherwise, people are going to discuss is that 10%, 90% all the time. A lot of majority of the discussion was spent on the reliability, which should be given by the exercise group.
Well, we did have a paper on reliability, as you recall, that looked at launch reliability and such things. So again, I think one thing we need to think about over time is doing exactly that, so we understand that it's been said it's humanly impossible to have a mission that's 100% successful. We just don't design missions like that right now. And but again, we need to sort of quantify that and show how can we get as close to that as we need to. One up here.
Timo?
Yes, I would say that it's, in some way, I feel sorry that this time the disaster management people didn't have anything to clean up on the ground. So in that point, I would consider it as part of the scenario to later determine the failures or come up with funny ideas why something failed or the asteroid behaved differently so that something ends up impacting to give them some work to do on the last day at least.
Well,
so
in the last...
that was what I would suggest, that no matter how it goes, even if the deflection comes up with a perfect scenario like this time, in some way there happens something for them to do.
So we did think about that, but that's happened in almost every single one of these exercises.
Yeah.
And so if we don't have a scenario where the players can win the game, then eventually we start to give the wrong impression that planetary defense missions are doomed to experience malfunctions, and that's just not so.
Yeah.
So we can find other ways to engage the disaster management people without baking in a contrived failure.
Let me just say that, again, as was said, we did a real job on Los Angeles here recently, and we also took out Houston and somewhere in Washington, D.C. before. So, again, we're sort of equal opportunity destroyers here. But we wanted to give an option here where you could win. And that was a real challenge. And so we wanted to test the decision making to see if, in fact, decision makers could, in fact, win this scenario. And I think Paul did a good job of that.
Okay, Andy.
Yeah, from a player's point of view, I also completely agree that I admit that some of my thinking, sometimes in the back of my mind, sometimes in the front of my mind was, we know something's going to hit Tokyo. So, given the tragedy in Bangladesh a couple of years ago. So that was part of here's why I think dunking it in the ocean is going to work, because that disaster is going to be much easier than the inevitable nuclear, radioactive meteorites pelting down on Tokyo. So I wanted to congratulate you for having us win, because that, I think, helps set us in future years to think, okay, maybe
you can win.
Maybe we can win.
Right.
That's
Yes.
exactly right.
Yes. You can win.
Which is real life, yeah.
We have questions up here.
I like it. They're passing
All right,
the mic around
Clemens.
up there. Go ahead.
Yeah. So yeah, thanks for the exciting exercise. I thought it was very, very well done. And I just have the observation. I think the biggest improvement you can make, which is probably hard to realize, is to have non-technical people as leaders. Actually, like
Right.
people without technical knowledge and without their own vested interests, depending on what they research in their everyday life. Sometimes I had the impression that the discussion by the leaders was biased towards nuclear devices.
Yeah.
Okay.
I think that's an interesting point. And
Yes.
again, one thing we tried to do is to make it open. We had opportunities externally so people could watch parts of this and send us comments in to make it so that leaders could watch these videos and do that. But one thing it'd be nice to know is how we can actually get them more involved. And I agree, it would be really nice to have that.
Yes, Rob.
Hey, Paul. This might be a difficult thing to model or set up, but some of us talked about it in the past. But what about setting up in a backwards Star Trek-like 4-next loop? A flash is seen over Los Angeles. What happened? And then we back it up 3 weeks before impact, and then we back it up several months and so on, kind of looking at key decision points as to what you might do. But that's a hard thing for whoever organizes it. You could call it Operation Hindsight or something like that.
Yeah. Okay. And Rob, you can lead that one. Okay.
Yeah, that's right. That's right.
Cheryl.
I think the one thing that was interestingly new in this exercise was making us think about over time what would be the impact on the world market and the economics of things.
Yes.
And in doing so, a lot of our effort, we are assessing everything in terms of a post-collision effect. How many lives are going to be lost? How much property, infrastructure, tsunami? All these are post-collision effects. But in reality, because of the long duration times that we would have, none of us are specialists here. Maybe we need to have some consultation from economists. That over the years, it could be really devastating to markets and countries and all. And of course, the way we message is going to impact that in a big way. So I don't know where you get that type of consultation, but that would add another very realistic piece to be considered.
I think it's a major omission that we've talked about this in previous years, but I agree with that completely.
Yeah, good.
I'm sorry? Invited talks from
Nice
economists.
Nice
That's a great suggestion. There are more comments. I see one in the front row.
Just to follow up on that comment, oftentimes we're in a situation where we're making the choice between an eastward and a westward deflection, which is shifting risk from one part of the world to another. And if there is economic fallout from that, there is going to be actual economic pain that follows the trajectory as you're moving it along that impact corridor.
Yeah, and to follow up on those points, one of the things that became clear to me this morning is that the uncertainty associated with an incoming object that may or may not hit a given area can indeed, in principle, have devastating effects on the economy and the culture and all sorts of consequences that are not physics-based that we don't normally think of. And so, given the potential severity of those consequences, a small, inexpensive, rapidly deployed flyby mission, to characterize the asteroid quickly and eliminate a lot of that uncertainty could save a nation. And I don't think we've thought about that before.
Okay. Who has the mic up above?
I back up
Let's get Nahum
all
up
the
here.
comments, and I agree with the economist. I would go a little even further and say that I understood from previous years that sometimes you had psychologists coming with those, massive sociological impact. You could have sociologists coming, and even if they can't come to the conference or they don't see a reason why they would give a talk at a planetary defense conference, I don't know, if you have a difficult time bringing them, emphasizing, this input from the leaders, make them understand that those leaders don't have to be policy people, but they can be lawyers, they can be economists, they can be sociologists, they can be psychologists. You have this whole branch of knowledge that we can bring here.
And the lawyers, too.
Yeah. Yes.
The lawyers, I think they have a say. We didn't get into the possibility of an East versus West deflection battle, but this certainly was a scenario that in which there could have been one country wanting to go east and one country wanting to go west, and there's many different plot lines.
And let me just mention that Linné Druby basically gave a talk about the legal group that's been supporting the same page, and I think that group may want to have some more direct input into this group as well, maybe for the next one.
Yeah, I mean, my comment goes in the same direction of what was said here. I think perhaps we could concentrate a bit more on the decision to act really at an earlier stage. I mean, here initially the announcement was there was a 1% chance. And of course, if there is a 1 week conference, it's not going to drop to 0 on the second day. But then it jumped immediately to what was it, 96% or so. Then of course, everyone knows you have to take any possible options. And there were in principle too many options still at that time. I mean, in the end, we still could have launched some additional spacecraft. But if you go to 10% and try to involve some real decision makers, that's what we tried already this time. Maybe we have to do a little bit better, or get then legal implications to concentrate more on the options initially, that you come up with something where if we do not decide now to launch on a 10% risk, then only the nuclear option is left. I guess that will be also a realistic case where we could put a little bit more emphasis on the technical possibilities to deflect the primary or secondary later.
You mean the early possibilities?
The early phases to take the decision, and then reducing the options. Maybe you could even then run 2 parallel options depending on what decisions you took.
There was a limited number of options that I was able to run, and I was initially going to go to 26% or some intermediate percent on the day one. But in order to move it along and get to the decisions that I wanted this scenario to take, I chose immediately to go to the east. And then you would know that the eastward versus westward debate would be right away. I think that was important in retrospect.
Yes, here.
Nahum.
I asked Siegfried this morning about how he would recommend the next exercise to take place. And I think he had a very interesting suggestion that will allow us to explore many scenario options and letting you a few more hours of sleep. I didn't see the microphone go to Siegfried, and I suggest to listen to his suggestion because it is very interesting.
Well, I guess we'll get there, but...
Okay. I'm over here with the mic for quite a while.
Yeah,
Okay.
Yeah, I was going to say, Ed, you've got a mic. You want to go ahead?
Let me a couple quick comments while it's getting over to Siegfried. But first off, these types of scenarios at the PDCs remind me a bit about the way we used to train to fly the space shuttle, which was always a bad day. It was always worst case, and so on. And those, I mean, you could never win in the simulator because it was just failure upon top of failure, or sort of off on the edge cases, which is fantastic for learning, for understanding systems or how the system works. But they don't help you for actually getting better at real live operations, because those aren't the things that you're faced with day to day. So the way we would train in jets is you would train to do things more about how you would more likely get more likely situations, single failures or more simplified cases. So in that light, I think it could be helpful to consider, if you take a look at, say, LSST, where is the maximum number of asteroids it's going to discover? Sort of around 70 meters, I think, somewhere's around there. It's a little bit less than 100 meters. Steve, you probably know the answer to that, but it's not that large, right? And so it might be good to try a case where, and it is in a remote area. But just so we think about, so you don't get to thinking that the 300-meter case is the likely case. It's not. And over Tokyo, it's not. I understand there's a learning value to it. One last comment about I don't agree that inviting psychologists and economists and people like that is necessarily the right thing, because I think that changes the character of the conference. I think this is a technical conference, which I really like about it. I think that it's not bad to do that, but I think that's a different conference.
Okay, Dan.
Yeah, I was just going to say, first of all, I'd like to echo the comments about winning every once in a while. I think that is good from a public perception and all that.
Good.
But to follow up on the economic aspects, I think that is really important, and just the impact of the potential impact to everything. But one follow-up on that is the recovery. You know, after we've now successfully diverted this impactor, and everybody is kumbaya, and there's a big party and all that, there is a cost of recovery that should be characterized along with that, because that helps to fully flesh out the economic and the social impact. And there's going to be some positives and negatives along with that. But just you know, running it out a little bit farther than just the day of.
We're going to need a team of economists on this development
and
scenario.
To follow up on that, maybe a follow-on conference, like a two-part, that you have the technical PDC and then PDC economics or something.
Okay. All right. Andrea. And Al, but Andrea. Go ahead, Andrea.
I like this exercise, but I dare to suggest for the next time to choose a somewhat less extreme example. Let me explain why. We have to look at things in perspective. 20 years ago, when we started doing this kind of job, everybody was worried about the 1-2 kilometer asteroid impact. Now we are working on the 300 meters.
Yes.
What is going to happen in 10 years?
Yes.
Well, we know already. At the end of the 20s, as a result of things like the European Fly Eye Survey and the LSST, the 300-meter asteroid will all know.
Yes.
Which means the prediction time for a possible impact will grow to 100 years.
Yes.
So at that time, either you make a prediction for a large impact, but it is 100 years in advance, which is, I don't know if this is an interesting exercise, but it's realistic, or it is a much smaller thing.
Well, we'll need a much longer conference if it's a 100-year scenario, believe me.
So if it is a much smaller thing, rather than having as many alternatives as this time was very interesting, nuclear, non-nuclear, the alternative will be deflection, evacuation.
Evacuation.
So that will be a different team, and I think it is more realistic. That is, the next thing which will happen is this one. Let's be clear.
In my defense, I just have to say one piece of information. I chose the size of this object was, or the absolute magnitude was H equals 21.9, and we only know of 40% of that population. So if you just look at the H value for this scenario, I think it was not entirely unlikely now.
Now it's not unlikely, but in 10 years' time it will become unlikely.
Yeah, okay. Al, finally your turn.
Yes, okay, if I may return to the topic of 10 minutes ago when I first took the mic. We were talking about the improvement of considering the economic aspects and leading into the event. I was merely going to suggest that, and I do this with some mixed feeling, that you might think about the post-event consequences. In other words, if you were to take the specific option and dump it into the Pacific and get a, you know, you make a very visible and profound display of the power of nature and the danger that we face, and it could transform the way people's minds work, and that might be worth exploring. And I offer as an example, when you all go to the airport tomorrow, you will suffer some of the consequences of an event that happened 16 years ago.
I'm sorry? You lost me there.
9/11.
Oh, thank you. Who else has the mic? Siegfried has the mic. Excuse me. In a moment, Siegfried, and then.
So first of all, Paul, let me thank you personally also and your team for a very, very good job. I think it's really did an excellent work, and you probably didn't sleep much. I have only like 3 little ideas. First idea is you should really take on a bunch of more people to help you with that.
Yes.
Because the other ideas are all based on more work, I'm sorry. The second one is, so I think we mentioned that public participation is very important, and public outreach is also very easy with this topic. And I think what could be done is, for instance, to make real public interaction get a good view of the public interaction by making the web page where you just put some votes on the web page. For instance, if you were the public, would you vote to make the nuke explode sooner or later? And that could be done, I think, reasonably easily, because there are some web masks, where you can just click, and you could also get a very good cross-section of the nation of people doing that.
Yes, now we did have remote participation in this exercise, so we did have the ability to drop in comments, but it was very difficult to adjust on the fly according to votes coming in. So we weren't really able to do that this time.
Oh, that's for sure, and I'm not saying you have to do it interactively. It would just be interesting what people would choose, even
it would be
retrospectively.
interesting, yes.
And the second thing, or the third thing is actually, and that requires much more work, I guess, is that I had a feeling that some of the groups were fairly large, so that the discussion were not able to accommodate all the comments in the time. So what we could think of, if we had the manpower to do it, is to just split the groups into several parallel strands of these scenarios, where basically you have 3 groups of leaders, 3 groups of things, and that would also kind of evolve or reflect all the decision making in a very nice way, statistically speaking. Because if you see that like 3 out of 4 groups are choosing a certain way, could indicate that that is a very reasonable way to go.
Okay.
Thanks.
We have good points. We have one right here. Do you have a mic? Let's see. Someone has a mic here. Oh, yes.
Sorry.
Thank you. I didn't see you.
I wanted just to stress that there was a very nice interaction among various groups,
yes.
Especially the decision to act, communication, and the impact effects, because this business of the nuclear thing really resumed a background issue that was not dealt with frequently, and then it raised a lot of ghosts, and then we had to decide between a purely technical decision and people which are doing operations know very well that device may not work,
yes.
and then also from the communication point of view, the perception on what means having a nuclear device somewhere. So this was, in our opinion, very, very interesting. Really.
The idea is just to get it discussed, and so we at least understand what the issues are. I think that was the idea. Yes.
I would like to thank you for possibility to be part of it, and thank you, Victoria, amazing leader of our group.
Yes.
And I wish you at least one president here, real president,
yes,
or
that's
prime
right.
minister maybe.
Yes.
So I would like to spend more time for that, but I'm not sure it is possible. But I've heard from Detlef and from all the people who understand something in real life, in real way of making decisions. Maybe we should reorganize the way of we are making decisions. Is it close to real life or not? This is my question, and maybe you should think about it. Is it real or not? Maybe Detlef will answer. Thank you.
Detlef?
Well, that leads into what I was hoping I have a chance to say. I think we sort of converged to a more realistic setup of the groups, and my recommendation would be that in the preparation for the scenario, we spent the same amount of time or a comparable amount of time, probably it's much faster, that you spent for the technical preparation, also in the logistics. So how do we set up the groups? To me, I was in a different group. I think we found our place in the end, but something like decision to act, that just is not a name for a group. You could call it decision makers, and then you also have to define whom do you mean. Do you mean Lindley and Gerhard and me, or who is it, or our director general? I think that deserves a bit more explanation in the beginning, and that leads me to another point. I also still think that in the beginning of the conference we should teach each other. We need education on what's already there in terms of the setup. So what's really the job of Same Page? What's really the job of I1? I1 combined some of the groups, and like I say, I was very happy that during the conference we converged to that. But we could make that maybe more clear. We now know, but maybe then at the next conference we have new people. We should have a bit more introduction on the logistics and setup of the groups.
In the last conference, we introduced I1 having a significant role, and Same Page, we heard Gerhard speak on day 1, I believe it was, on Same Page. So there was an introduction to the Same Page function even on day one here, and then same page played a role in the scenario. So I hope that helped. Yeah.
We have to improve on that. I'm just saying, yes, I know, but it wasn't apparently good enough from what I saw then in the first 2 days. We adapted
Fair
quickly,
enough.
so don't get me wrong, don't see it too negative.
It's a good.
But we can do better.
That's a good comment. Okay, Gonzalo, and then we'll go over here. So.
Coming back to the economist issue, I would like to share my experience because a couple of years ago I gave a talk to the largest economics firm in my country.
Yes.
It was an audience of over 100 economists. And the first comment after my talk, it was a talk about the hazards or impact hazard. And the comment was that they face this kind of risk analysis every day. I mean, they are very usual to this risk analysis.
Yes.
So I think many economists will be willing to participate in one kind of exercise like this.
Okay, that's a good point. Right here. Yes.
I just wanted to respond to Ed's comment earlier and also repeat it in another discussion we had earlier. The most likely case is it's going to be a very small impactor, less than 100 meters over the middle of nowhere, and you're not going to have enough warning time, and you're just going to let it drop and evacuate the area. But and I think it is important for us to repeat that the exercise here is a very specifically chosen example to be highly complex and require a lot of decision making to create an interesting discussion.
That's right.
And a lot of the time, you're not going to have a lot of choices. It's going to be a very simple choice. And either because of lack of warning time or because the asteroid is going to be big enough that you don't have a lot of deflection options.
Yes.
And I think that's an important point to make.
We're looking
clear
at
to the
one
public.
particular case with this in 10-year warning time. So there were many options available that would not be available if we had a 2-year warning time or a 2-week warning time. Dave.
Yeah, this is not an advocacy for a big change, but it is possible to bring some of these people in. And one of the most interesting conferences I ever went to was organized by Leonard David, and it was a mixture of, it was on planetary defense. It was a mixture of scientists, risk analysis, a couple of politicians, a couple of people from the insurance industry, and 2 or 3 politicians. It is possible to get an interesting thing like it. We could have a half day on that sort of thing.
Yes, I agree. I agree with that. Barbara.
I was just going to say, we've done the scenarios in quite a different fashion, I guess, if you will. And this one was different from all the others in that it was ad hoc. This was developed at the conference as it was going along. So in the past, we've had documentation available where we've spent months ahead of time preparing to do this. And we still spent months ahead of time, but not all the information got presented because the changes were made ad hoc. And so taking that into consideration, I think it was a very exciting, it was a lot of...
Thank you.
It was exciting, it was very interesting, and it was neat to see it develop. However, it was a little frustrating being as somebody who normally provides information because we were just cranking this stuff out as fast as we could and none of it was being used. So I've got a whole set of economic information, for example, that we never had an opportunity to discuss.
That's right.
That being said, I think I also like the idea of just having the scenario only, like we've done in the past, the one that we did in Pasadena, when we had the actual FEMA representatives and whatnot to participate. So either way, it turned out really well, but the idea of this was more a combination conference, and I think that in doing that, you did it well.
Okay, good, thanks. Okay, we got a couple more. Timo has a mic.
I just wanted to add one short point to the most likely impactor being the small, let's say, Tunguska or slightly larger ones. Once these big new survey telescopes come online, we might have the situation that we have a dozen of those all the time. So we're in the new situation of dealing with a dozen mini apophyses all the time. So that they're all on vastly different orbits. They may be harder to track and follow up than the objects of the size class we had now. And so that this will be a totally different scenario. It will not be just one. We may have to choose which one could we afford to let hit, or which one can we track, and so on. So it opens a whole new can of worms.
Yeah, can of worms there. One at a time is my motto here. Yes, here.
There are so many aspects to the planetary defense issues that maybe it would be worth to select for the exercise 2 or 3 topics that would be discussed in depth. For instance, diplomacy, communication, and from a scenario that would be not evolving. I mean, it would be the same at each exercise for dealing with different topics. For instance, the scenario that has been presented today, this week, could be used for the next exercise for addressing commercial issues. And but you see, from the different aspects of the same scenario, I don't know if it's possible or if it's, but it's my proposal.
Okay, very good. Stas, a couple more, and then Ramona. Stas, right? Oh, okay. Yes, Stas, go ahead.
Yes, so we are the PDC. The D stands for defense.
Yep.
I think we should take a page from national defense. The military would not stand for using weapons in the field without testing them. And I think that we should advocate to do the same with weapons for planetary defense, or mechanisms for planetary defense. Let's not call them weapons. We have to find ways to disseminate to the real leaders in the real world what things have to be tested and refined and have them in our arsenal. I'm not sure how we can do that, but something to keep in our minds.
Of course, starting with kinetic impactors, we need to demonstrate kinetic impactors as a start.
Yeah, by the way, I might mention that one of the things that we want to do before we totally close the conference is we want to try to get some carryaways from this that we will put in the report, and that's probably one of them. And we've had that in the reports in past conferences as well, that we need to test some of these techniques, so yes.
Yes, right here. And then we'll go to Ramona. Yes.
Well, first of all, this is the first time I was at this conference, so I want to commend you on the depth of the detail you present every day for this scenario. It was quite amazing what you and your team put together for this,
Well,
so commend you on that. But on one of the points I realized on the first day is it seemed that with the 1%, the leadership seemed very apt to spend a good amount of money at the beginning. Yeah. And one curiosity, I think that I don't mean to make more work for you for this, but I think it'd be instructive if we had maybe 2 potentially hazardous asteroids, and they had a fixed budget. Maybe they were both at 1% impact probability, and then the leadership had to decide how they wanted to divert resources between those 2. Maybe they were 2 different magnitudes when we observed them, and how they would then divert the resources in order to investigate that. So maybe a fixed budget on day 1, maybe. And then the budget gets relaxed as we find out something may impact us.
I would agree with you that the budget concerns should have been a part of the scenario, and I'm not sure they were, because, I don't know, 9, how many spacecraft did the leaders choose to send? What was the budget for that? It was enormous. But I would not encourage going to multiple asteroids heading for the Earth at the same time and all of that. That's extremely unlikely. But I think the budgetary element was not enough of a part of this. I don't know. Romana, yes.
Yes, I'd just like to briefly comment that one other aspect I truly appreciate, and of course I thank you for inviting me also on behalf of the Office for Outer Space Affairs, the international character of this conference. This is the first time I hear that it was also organized here in Asia. So I think in future, in planning and preparation, I think this should really be the trend to really engage experts from all the continents and really try to sensitize them globally. So that would be
excellent. Yes.
Yeah, I might mention one thing that we've heard, of course, is that there's always this idea of, if you will, taking the hit. But I guess the question is, who decides that? And so I'll throw that on the table. The second thing is that, as you know from Apophis, these things can go away too. So I think maybe you come to this and you see the fact that we're going to be playing a scenario all week. We kind of give away a little bit of this. You know, we could fool you guys one of these days and have it miss. So I just keep that on the table.
Yeah, all right.
And then think about the resources you've expended and what the consequences of that might be.
Another way maybe to find the best way how to communicate with general public, world leaders and decision makers, because it's not so easy, because they are usually problem with understanding word like probability.
Yes, yeah.
But we talk no more about it. It's also a really big problem.
You don't realize how difficult it is to communicate until you're writing a press release as if you're a press agent.
Yeah.
And I wrote most of those, and they're difficult to write in a clear way without causing a panic, and the question of whether to even mention nuclear, it's not clear exactly how to write these, and so communications is a huge issue. Yeah, Kathy.
I noticed that for the third time in a row, this thing snuck up on us from the south, and after the beautiful, after the beautiful presentations by the radar folks, I was wondering if we could add to our after actions to have some sort of recommendation about improving radar coverage.
Hear, hear, by the way. Yes, hear, hear. I agreed, and we didn't get to the end game here where radar played a role because we had characterization already in space. So in situ characterization removes the necessity of the last-minute radar. However, early on, radar was too powerful to put into this scenario, so I made this object too far away for the radar. You notice that?
Yes,
So
I know that's intentional on your part.
that was intentional.
And I appreciate that. I do see that in real life there is some sparsity in our coverage, and that might be worth taking away as an after action to recommend.
I fully agree with that.
Thanks.
One more here? Yes, go ahead.
This was really wonderful, and for someone who hasn't been really part of the planetary defense community in the past, this was really fascinating. And I wanted to suggest another forum for this workshop in the style of, say, the Caltech Space Challenge or the Space Station Design Workshop, where you engage the graduate students, and you could even repeat some of exactly what you've done here with that group. I mean, it sounds like there was a decision tree that you had, and some paths weren't even explored. So a lot of that could just be reused for that.
I would love to reuse a lot of this, and having done all the work and alternate endings. By the way, we did many endings that you did not see that we could use in other forums.
Yeah, honestly, I think the graduate students would benefit tremendously from
Good point.
engaging with something like that.
Do you want to wrap this up?
Yeah. Okay, I think basically we've had a really good discussion on this, and again, you can always submit your comments to us also. You have emails and so forth, so just email us your thoughts. We'll probably start thinking about the next conference in another year. Take a year off because these things can be fairly intense, as you can tell. But again, if you have thoughts about that, it would be nice to know. And again, we tried something different this time, much more interactive. We allowed you to pick the groups that you could be in, and the thought was that we would have experts gather in the groups that they did, and I thought that worked out all right, although some were, as was correctly stated, a little bit too large, I thought. But again, I don't know how to break those up very well. So given a technical conference like this, we just we had recommendations from past conferences that we go back to that model, so we did. So again, anything like that you want to put in relative to how we might organize it, specific groups we want to get rid of, we've got here, like you've said, Detlef, that's fine, and we can adapt. So again, I appreciate the good discussion, and if you have any more thoughts, that would be great. If there are other opportunities for doing this, for example, the one that was mentioned was in looking at press releases. How do you inform the public? There was one conference that was really dedicated to that aspect of the problem. If there's an opportunity for a conference where a group of economists could be informed about these kinds of things and have them think about it in more of a global sense, that would be a nice thing to consider as well. So potentially we could take some extract of this and do that. Also, the final report will have a pretty good summary of this exercise, complete with the press releases and so forth. If you look at all of the past conferences we've had where we've had exercises, that material is there. And so it is a resource. One of the objectives here is to build up a body of information that can be used for educational purposes and will help inform the kinds of decisions and things that need to be made in the long term. So again, we invite the comments on that, and this is sort of a unique conference in a sense, and I think that's a good idea. And so thank you very much for that. I think what we'll do now is, if you look at the calendar, I believe we're scheduled for lunch at 12:30, which it is. So I would suggest we have lunch, and then we come back, and what I'd like you to think about then is, what would you recommend we carry out of this conference as specific observations or suggestions of things we need to do, such as testing, any other things that we've looked at? We might ask the session chairs for each of the sessions to kind of give a quick thought about what the takeaways were from their sessions. So if you don't mind doing that, session chairs, maybe we can come back and start there. Thank you very much. Enjoy lunch. Any comments the session chairs would want to make? And we'll wait for these guys. Yeah, hang on a sec. I just want to wait for these guys to settle down up here. Excuse me, guys, if you want to talk, you want to go out in the hall? Okay, that worked. Session, let's just go down the sessions, and again, if there are any key inputs that you'd like to have us take away from your session, then we'll do that as a starting point, and then we'll just throw it open for discussion. Session 1, key international and political developments. Romana, anything that you want to say that you think is a key point that was made in your session? Oh, you need a mic, huh? Aha. Are we out of runners, it looks like? We have only one mic? How can that be? Perfect. Thank you.
I just want to say that, or sort of point out the words of the ESA Director General when he said that working towards planetary defense global alliance is really important. That should be sort of the goal of this community, but also realized at the political level within the Committee on the Peaceful Use of Outer Space. So that would be sort of one thing to take home with.
Could you repeat that one time? I think I kind of missed that point. Go ahead one more time.
Yes, he finished by saying that he looks forward to working towards a truly global planetary defense alliance and all the efforts that contribute to that. So I think that's really important because it shows the trend. Also, as I said, the 3 global development agendas, the 2030 Agenda for Sustainable Development, the Paris Agreement on Climate Change, and the Sendai Framework on Disaster Risk Reduction, all 3 tend to work towards strengthening and building resilient societies. And this is an important pillar of those endeavors. I also think it was really important that the host country brought in political decision makers from the parliament. I heard from my Japanese friends that this was quite widely broadcast in NHK primetime on that first day.
Wow.
So that's quite really, I think, a really good achievement. Yes, and as I said, on behalf of the Office for Outer Space Affairs and the Committee on the Peaceful Use of Outer Space, we look forward to working both with Same Page and ION, as we have been so far, but also in moving this really forward. If there is a possibility to bring these issues either in 2018 during the Unispace Plus 50 conference a bit more forward, but also after, I'll be glad to work with you on this. Thank you.
Great. Could you describe what Unispace Plus 50 is?
Yes, Unispace Plus 50 is a special segment of the committee session next year. It basically marks the 50 years of the first UN conference on exploration and peaceful uses of outer space. And as I said, planetary defense and the same page and I1 are results of the third Unispace conference held in Vienna in 1999, so it took quite a long time to come up with the recommendations. Now, Unispace Plus 50 is different in character because we want to have the preparatory work already completed and have the main decisions taken in June 2018, okay. 20 to 21st June 2018. Okay. And as I said, there are 7 thematic priorities that we work on. The first one is global exploration. So we're looking at, we've sort of identified, or the committee has identified areas where strengthening of international cooperation and coordination, like in planetary defense, is still needed. So exploration is one of the areas. Then space weather, space for global health, building resilient societies and climate change issues. So these are the and capacity building.
Good.
Yeah.
Excellent. Sound like there might be an opportunity there. So if you see some way for this community to have some input into that, it'd be very nice.
Yes, because prior to this high-level segment on the 20th and 21st of June, we will have 18 to 19 of June some symposia and outreach events. So this would be a good opportunity, and we can discuss how we can build this in.
Okay, good. Thank you very much. Okay, any other comments on session 1? Okay, session 2, advancements in progress in neo-discovery. Alan or Giovanni, either here? Okay, good. Let's see. And again, I think we'll look back through the presentations on that one. Session 3 is Linny and Alan Harris. And are they?
I think in all the examples we've had so far in these conferences, we've seen the importance of physical characterization and the ground-based, not only ground-based, but any sorts of physical characterization and sort of tracking are very, very important. That includes, of course, infrared assets, if you like, and radar. And it is, I think, vitally important for our community that investments in these astronomical facilities continue or even increase. And that includes also, of course, space-based telescopes. And I think that's the thing we'd like to emphasize most of all, that we, Arecibo,
right.
Keyword, Arecibo. Yep. I can see a few people that have looked up, yes.
I remember, last conference was it, where Arecibo funding was in question, I thought.
Isn't it still?
Is it still? Really?
So I think we need to, those of us that can, and I'm not included, I'm afraid, should stay on that. That's vitally important, yep, obviously.
Yep. Okay, very good. Any other comments on that one, on that session? Let's see, that was, and then session 4 is deflection and disruption models and testing.
Yeah, so that's us.
Yes.
Okay, so I think the session showed that there are a lot of parameter space to cover when you want to predict what happens in an impact, kinetic impactor or a nuclear explosion. What I would say that, I mean, the Livermore National Laboratory is doing huge efforts, and I think is leading the efforts in these things. And I would like to see more people from the hypervelocity impact community contribute to these efforts, because we have Livermore, we have APL, Angela Stickle, who actually is organizing a benchmarking, but has difficulties to get the results. So I think we should encourage all the people involved in modeling to contribute more to this problem, because we need to be able to really understand the different code, the different outcome that the codes have, because it's complex physics. And also the parameter space is very large. We saw you can have a rubble pile, but what is a rubble pile, etc. And what I observed is that it seemed that there were more people coming in the past conferences on this problem. Some of them are retired, like Kevin Hausen, Keyhole Risk, etc. But some others also are working on the problem, but do not necessarily come. So it would be nice to encourage this community to come again, so that we have an even richer session with a different kind of modeling. I would say, and also experimentalist.
Experimental stuff, right?
I think that would be good.
I'm just curious, is there general consensus that the models are producing accurate results these days?
Now it's, I mean, we had an IDA workshop in Nice where there were some discrepancies between the codes. And it's always difficult to know whether it's because different initial conditions are used, or whether it is really the modeling of the damage which is different, or even the numerical techniques. So Angela made huge effort to try to understand with the others what were the differences. It seemed that there, at least for the tests that were done, there is an understanding, but obviously more is necessary to be done.
Okay. And are there calibration cases that are used for comparing models?
Yes, there are some benchmarking that are defined, but again, there could be more.
Okay.
I think it's an important problem because, of course, everything relies on for the prediction, on the modeling.
Yeah.
And it's not a magic box. There is a lot of physics inside. I wanted also to say that we should also have in this session an effort on what happened on the longer term after the impact, like the fate of the ejecta, because I saw in the scenario that the different kinetic impactors come one after the other after 5 days. And I do myself the modeling of the fate of ejecta, and 5 days may not be enough to clear the environment from the debris, especially in a binary system. And we still lack understanding on the ejecta properties, especially the low velocity one, which contribute to the risk, basically. And so we need also an effort on that. What happened after the impact, but on the longer term than just the impact itself.
Okay, very good. Thank you.
So the bottom line is there is still a lot of things to do in this kind of session, and I encourage this session to be at the next Planetary Defense Conference again.
Oh, yes, good. Okay, session 5, Nahum.
We heard an interesting talk about the Hayabusa 1 and 2 that's both funded and successful and ongoing. Hopefully we'll bring some more science back to the Earth in just a few years. And we heard a few interesting talks about the deflection testing missions, AIDA, that's going on, partly funded, about a workshop that's going to take place in just a few weeks. And so hopefully this approach is going to be successful and funded and implemented. We heard about the Asteroid redirect mission that's in trouble. We heard about some of the technology demonstration, like the gravity tractor demonstration that was supposed to be part of that project, and I guess will not happen, at least not in the near future. We had a series of talks about NeoShield and its variant of NeoTwist that's partially ongoing and very interesting in terms of demonstrating some planetary defense capabilities. We heard an interesting talk about campaign reliability, how to ensure that the overall campaign is in a comfortable zone of success that is requiring additional launchers and payloads over just the bare minimum to deflect the object. That's not enough. We heard a talk about concurrent engineering for designing of those payloads, and some interesting concepts about solar cells and directed energy. Interesting concept, novel part of the session. And overall, it covered a wide range of campaign and mission designs.
Okay, very good.
Thank you.
Yep, sure. Session 6, impact consequences. Mark and David Morrison. Any
I'm right
comments?
here.
Yep.
So we had a session on impact consequences. We also talked about risk. And of course, impact consequences maps directly onto risk, risk being probability times consequences integrated over everything that can happen. And there was a lot of discussion about entry physics, ablation, fragmentation models, what happens when things hit the ground, what is the blast damage on the ground. I think the big disagreement was over tsunami, but I'm on the short end of the stick on that one. But ultimately, I think in some ways that's kind of inside baseball, because even my worst case, I don't see it as adding significantly to the risk. It may be a non-zero addition to the risk, but it's probably not a significant factor in the overall risk. And let's see, we had a couple of really interesting talks from Galen and Suhail on the impact onto water. And let's see, also Daryl. One of the things that I think was nice was that we had released information about our scenario, about our exercise, and that allowed people to focus and be more specific in applying the risk analysis and the impact consequences to that scenario, so we could sort of compare for a specific impact. So, normally when we give these presentations, we're very general, and we had something to tie it to. So I thought that was really helpful to our session.
Yeah,
and I'd like to do that again in 2 years.
I know she actually also had some discussion of some of the secondary effects, like material lofted into the stratosphere and so forth.
We did. There was a little bit of discussion, but that may be something we want to talk about more in 2 years. Maybe that's we can all come together and model that, much like we did for tsunamis last summer in our workshop in Seattle.
Yeah, I think, again, to do an overall assessment, I would expect sometime the leadership will ask, what are the long-term effects of an impact versus the short-term effects, like the blast damage and so forth, that we've got models for. But what happens when you start lofting stuff in the atmosphere and so forth? And I thought a couple of good papers on that, so it was nice.
And Galen had a little bit of that, what happens when you get all this, maybe it was Suhail, now I can't remember, but lofting water vapor into space, and what would it do to the ozone?
Yep, that's good. Okay, let's see, session 7, disaster response, Lindley or Barbara Jenkins?
Yeah, I'll start off, and then Barbara, if you want to add something, you can. I think this area, disaster response, is sort of a good news, bad news story. In that I think it's good news that at least in a couple of countries, major areas of the world, impact emergency response, impact disaster has become a legitimate part of disaster planning and is getting normalized into the planning and preparedness documentation. So in a way, we've become a legitimate part of the club. But it's, first of all, in just a few areas, United States and Europe and Russia also had some discussions with their emergency command as well, particularly after Chelyabinsk. But that's a relatively small part of the world, so other countries have a ways to go yet with that. And the good news is that there's been some pathfinding gone on with that in the United States and in Europe now that can be provided to countries as to how they might integrate impact disaster planning into their planning. So I think that's good news. We're making progress in that area when not too many years ago we couldn't get their attention at all. But part of the bad news is, though, I think, in that we still, although we've got lines of communication and discussions with them, we're not necessarily getting good feedback from them. And what I mean is, the conference is an example. They didn't have it high enough on their priority list, for instance, in the United States, that FEMA could even send one person to this conference who was slated to be this session chair for this session. So it's still maybe not high enough on their priority list, and particularly for giving us better feedback as to how we could prepare ourselves better for working with them in the disaster response community, the kind of information they need and the communications that needs to go back and forth. I think that's especially important because, as an example, Mark Boslow's presentation on the most frequent type of impact is going to be a rather small object, and shelter in place is going to be a very effective way of protecting lives, certainly reducing the injury level that could happen from a relatively common type of impact. And the way that you do that is through the emergency response community, making sure that they understand that just because it's an asteroid impact doesn't mean we're all going to die, and that if you just do a few, are aware and do just some simple things to protect yourselves, protect the citizenry, that the injuries and loss to life could be very much reduced.
Okay, very good.
Barbara, you want to add anything to that?
Sounds like maybe one thing we ought to consider is if we're having the conference in an area, we could invite the disaster responders in that area to come and actually, if you will, play the exercise with us. So maybe having representatives come to this meeting and do that would be nice.
The online interaction,
Yep.
we did have 2 different agencies, disaster agencies, submitting information to us during
Excellent.
the session. It was really good. It was really fun to have their input.
That's nice. Which agencies were there?
We had, well, let's see, they just gave me other agencies. They didn't give their names, but Mark Burtis and Sinus Schultz. Sinus Delberts.
The German Weltlagerzentrum was one of them. We also know that the Swiss Nationale Alarmzentrale was following us, and this English name is somebody else.
Mark Burtis. Yeah.
Sina Scholz was from Germany, and the Swiss guy was Matthias.
Ah, good. Oh, that's right, yeah. That's good. Okay, well, I'm glad we got some input from them. Excellent. Okay, very good. Let's see, the next one is session 8, Victoria and Gerhard.
Yeah, this was a bit a mixed session. So it was on impact risk assessment and on the decision to act. I mean, on impact risk assessment, so we learned that basically tools to accurately predict the ground impact corridor are now available. There was a second tool presented compared with the existing tool from NASA. So we have one tool now developed under ESA and one from NASA. And for the cases presented, they agreed very well, including these PDC artificial asteroids. So I think that is in place now. There was a second presentation given showing the general accuracy. So if we claim there is zero risk of an asteroid, it was pointed out, in reality it might only mean the risk is smaller than 10 to minus 7. So absolute zero is not really achievable. And then there were several presentations dealing with the decision process, which is in place right now. And also additional recommendations were made or warnings issued that we have to assure that, as it is fortunately right now, where there is general consensus that this is a good thing to do and that should be a worldwide cooperation on planetary defense, that one has to be a bit careful that not someone drops out if he doesn't think this is concern of me, or that things are being classified or seen as a security issue, so that somehow the international cooperation is affected, which is very good right now. And also there were presentations on what is in place right now, on the time you might have for warnings, and on the process of decisions in the various institutions. And finally, there was one presentation on comets. I believe it was the only presentation that focused on comets, pointing out, of course, there are much fewer of them, but they are bigger. You will have less warning time of just about 2 years. They are faster on average. And also, in addition, I mean, so that means it will be very difficult to deflect them. And they're also probably more difficult to predict because of outgassing, so their orbit is not quite as predictable. So that is something which is, I mean, for some reason not addressed too well. And I know it when journalists ask, yeah, how about comets? You say, okay, but right now the risk is much lower, and it's more important to deal with asteroids, where I would agree to. But maybe in 100 years, at the PDC 2117, all asteroids are known that could be of a real risk and are more or less under control. And we mainly deal with comets, so we do not know that. One should not forget about this.
That's right. Maybe we'll do a comment for the next exercise. Something to look forward to. Okay, let's see. In session 9, Public Education and Communication, Alex Carl and Ian Carnelli. Ian, are you here? Up at the top.
Thank you. I think there were 2 main points that I would summarize. One was the need of linking different databases and sources of information, and I think also it can be expanded a little bit outside the just communication domain, but also data sets for analysis, which was also brought by Andrea Milani earlier this week, and the data, for example, from Arecibo being one of the examples. So, okay, there was one conclusion of these new tools being available that are capable of mining data and correlating data and making also some online tools available for analysis of this data. And the second point is more on communication and the need to harmonize terminology, how we talk to the public, how we talk to the media. And I would say, yeah, that there are new, let's say, last year at least I could experience some new movements like the Asteroid Day initiative that was trying to do a little bit more of outreach with pros and cons. I could leave it personally in terms of fear-mongering and how you deal with that, and you try to avoid and do real education. So I think there are some good intentions out there, but there's a real need to have a common understanding of the terms we use, and I think probably as a community we also need, and would be interesting to involve in this conference, some professional communicators. When I prepared the ministerial conference, I could work with journalists, in particular a journalist who was helping me to, telling me how I should talk to politicians when presenting AIM. And I had some big surprises. There's things that I gave for granted in terms of understanding that were not for granted. It turned out that most of the terms we use, they don't understand. Even kinetic impactor. Kinetic is just complicated. Even orbit sometimes is just complicated. And I think it's quite interesting actually to sit for a day with a journalist and try to simulate how you would actually talk to these different stakeholders, be a politician, be it the public or kindergarten. Yes, so
that's right.
So I think that could be possibly something that we would want to think about for the next conference. I think having some some real journalists and professional communicators would be.
All right, good.
And now I think there are quite a few that have been. Patrick knows a lot of them in France who are acquainted with the topic, and so they could be involved easily in such a conference.
Mm-hmm. Okay, good. Thank you. Okay, so what I'd like to do now is just kind of go around and see if there are other thoughts that you have as to what we might want to take away from this conference, things that you thought or think that's important we should capture. So any comments on that? One up here.
So we talked about the possibility of launching early versus launching late. And one of the advantages of being able to launch early is if with some amount of additional investment, we would be able to put additional objectives to the mission. For example, some science goals or mining. In case we launch early and need to abort because the threat turned out to be a non-threat, we could repurpose the mission into something useful and not have a total loss on the mission. And this might justify launch early, have the confidence in defensibility, and if we don't need it, we can use it for some other purpose if we thought in advance to design that capability into the mission. The other consideration is we just talked about using a comet for the next object, and that would, I think, line up with the notion that we are going to be discovering most of the medium-sized objects in the next decade or two, and barring an emergency, they're going to be shifted to the non-threat area. We are going to be faced with small objects that typically are associated with short warnings. And this is kind of the comet territory. Mm-hmm. So perhaps we can pick an object that is a comet and can be replaced with a small object that comes with a short warning and cover some of these territories as an object for the next exercise. And the other idea is that we could actually replay some of the scenarios from the previous conferences and divide the groups into different groups that are going to be dealing with some of those scenarios that already cover a wide range of threats. And so each group will deal with it separately, end-to-end, throughout the conference, and will give us a report at the end of the conference what they have come up on their own with that particular scenario. And they could cover comets and small objects and big objects and things like this throughout their own internal discussions throughout the conference. They will be given time to deal with this and give us a report at exactly the end of the conference. What did they cover and what did they achieve?
Okay,
thank you.
You know, what that brought to mind, one paper was talking about this idea of having, putting some capabilities in the barn, if it were, where you'd basically have some deflection type, kinetic impactors or something like that, where you'd basically put together these things and let them sit in the barn, and then if they're not used after a period of years, you let them fly off on science missions and things. So that's an idea of being prepared to use those kind of things. What do people think of that? Yes. That's a great idea. Okay.
I would like a dissenting opinion.
Okay, what is it?
On the grounds that you shouldn't leave asteroid deflection technology sitting around where it might be misused.
No, this is not. Yeah, these. Yeah. Go. Yeah.
Sorry.
The idea is
to clarify. There's not. The idea is not to have them armed. The idea is just to have the spacecraft themselves built.
Yeah.
And so, they wouldn't be harmful. I mean, there wouldn't be any way to misuse them. They would just be spacecraft.
Yeah, be kinetic impactors, basically.
Yeah, just heavy spacecraft.
Yeah.
I'd like to follow up on that with the idea of a session that examines in detail the concept of spacecraft's long-term storage or rapid design, development, and deployment of systems. The idea that we need something and we're going to get it built very, very quickly, whether it's just a reconnaissance spacecraft or even the launch vehicle, so that we can start understanding the risks of that concept.
Okay, very good. Other thoughts? Yes.
Hi, I was told that so this is not my opinion. NHK is going to do the broadcast this on May 30th. So hopefully I'm not stealing thunder from the LOCs. NHK is that's Japan's public broadcasting thing. That's the biggest TV station, and they're broadcasting on May 30th from 10 to 10:25. So if enough people is interested, I can capture that, and maybe I can translate in English. But I'm not sure how much. That's going to take me a while if I want to translate that. But if enough people is interested, I might do that.
Ah, interesting.
You can like my website and Facebook, and if I have enough people, I'll do it.
So they're going to be doing a 25-minute thing on this?
Yes, sir.
Whoa. You'll all be famous or something. Okay, let's see. Other comments on things that we want to carry away? Yes, please.
With regard to building spacecraft and just having them sitting
Storing
around
away, yeah.
waiting,
Mhm.
I suspect that, at least among the public, the more expensive it is, the less likely there's going to be motivation to want to do that.
Right.
Within the military, I guess we already have such things, like nuclear missiles sitting in silos just waiting to be used
Yeah.
if they're needed. So, considerable resources have already expended to do that sort of thing, but for military purposes. But I guess the public doesn't have a whole lot of say in that. So I guess it's really a question of how much do you want to spend, and the more expensive it gets, the less likely it is to happen. And it also depends upon economic times. When times are fat, you can afford to do things. If times are tough, there's going to be less motivation to do that.
Sure.
What I'm kind of curious about, and I don't have a number off the top of my head, how much money was spent on like civil defense shelters back in the 60s, where we had these places that had food supplies, water supplies, maybe radiation sickness medicine set aside, unused, but just, in case. And that might be kind of a dollar figure we could attach to something like that. And I just don't know the answer to that question.
Right. Okay, good question. Yes, in the back? No, you're back further.
I'm in the
That's
back.
good.
Okay, I don't know if this is on. So both of these might be sort of self-serving because I'm involved in two things, but other people have brought these up, so I just want to put it out there. There's the mention that we should test out any mitigation techniques, whether that's something like the kinetic impactor like DART or the gravity tractor. I don't know if that specific explicit statement would want to be carried forward.
Yep.
And also the idea that flyby spacecraft can get give you a significant return. That rendezvous spacecraft obviously will get you everything, but that a flyby or a fast flyby might get you a lot of the way there more cheaply and more quickly.
Okay, thanks. Yes, Al?
To follow up.
Where are you? Up there? Yes, go ahead.
To follow up on the warehouse idea for the kinetic impactors, apart from warehousing kinetic impactors, it might be an idea to warehouse small flyby characterization missions and have them standing by, and any time something comes within, say, 2 lunar radii or some threshold that we decide, we simply send the flyby spacecraft to characterize it, perhaps even having a small impactor on board, a couple of kilograms, 10 kilograms.
Yep.
So it does give you a little bit of science, and it also has, you're exercising the characterization capability.
Yeah, the art and the targeting and such. Yes, exactly, good idea. Okay, go ahead.
Me?
Yep.
I think we're underestimating two important things here. People talking about building spacecraft and putting them in storage and having them ready for the event. Those timescales are going to be very long, and I think we're underestimating the rate of technological development and improvement. And I think you have a spacecraft sitting around for 10 years, and people are going to say, look, we can do the job a lot better now with improvements in technology. So And the other thing is that the technological improvements will allow us to get to the launch pad a lot faster in the future, probably, assuming that we're going to be expanding our activities in space. So that's one thing we're underestimating, I believe. So I don't think it makes a lot of sense to keep stuff stored on the ground, ready to go. And the other thing that has been mentioned, but probably not emphasized enough, in my opinion, is our potential future synergies between our activities in planetary defense and those of the asteroid mining community. And I think that this could be an important point for a future conference to explore in greater detail the sort of synergies, especially, I suppose, with respect to characterization, where whatever information we need on an asteroid in terms of characterization, I think would be of benefit to asteroid miners as well in these very early days. It is, of course, not clear at the moment how asteroid mining will fare as an enterprise over the next decades, but I think there are good chances that it will go forward, and I think we might be surprised at how quickly that happens, in which case we ought to stay abreast of those developments, and we probably ought to come together as communities.
Very good. Have you got a mic? No? Okay, right here. I'll get back. Yeah. Oh,
Alan Harris wasn't here to talk about the NEO surveys stuff, but one other thing that, again, just is a very obvious thing to shout out is obviously keep doing the ground-based surveys. It's important to have those support because of the great information we're getting from them, and also the characterization, but also the importance of doing the space-based survey, having that in there as a sort of a, it's the main thing that we need to do in terms of early warning, which is the first step in any type of planetary defense posture. So I think that's really important to emphasize.
Do we need to do anything to augment the space-based surveys?
Well, it'd be great to actually call a shout out for them. We have infrared is presumably the way to go, and it helps not only with the survey, but that ties into everything else you want to do, especially coming back to Al's point about the mining community. So if you have the survey, you know where all the targets are. It speaks to not only your science, it speaks to the asteroid mining, but also human exploration as well. You have all the exploration targets you want to go after. So it's a fourfold step, but primarily it's planetary defense. Find them early, find them early, find them early.
Very good. Okay, yes, up here.
Yeah, one addition to the warehouse idea. So you can certainly imagine to have a steady state warehouse if you just continue supporting planetary science missions that are producing the spacecraft every few years or every other year that are capable of doing these missions. If you're ready to now and then divert a mission that would go to a scientifically interesting target to one that's maybe of interest from the point of view of planetary defense or other related asteroid matters. So that would give you a steady flow of up-to-date spacecraft that should be flexible enough to do this mission. And we've seen this already with the reuse missions that went after doing their prime mission, went to some other asteroid or comet, like Epoxy, for example.
Okay, good, thank you. Other comments?
Connected to this and also to Alan Harris, Alan, have to slightly contradict space bus technology or satellite technology is not becoming obsolete so fast, so it's entirely okay to put a spacecraft in storage for 10, maybe 20 years. It will not be totally obsolete, it will be as good as yesterday if you have if you check it out from time to time. And the progress on subsystems and systems is not so fast. Okay, you have maybe once you have electrical, you have already done something, and you can use it for a long time. So I think it makes a lot of sense to put something in storage and replace it every 10 or 20 years, and use the old space before they become really old for planetary for science missions, as opposed to rapid design manufacturing, because that still needs a lot of time. You cannot make designs in advance, because that indeed, for example, even the availability of parts changes very quickly. So you cannot plan in advance and then just executing the manufacturing. That doesn't work. You have to do it all over again.
Mm-hmm.
So rather storage.
Might be a nice subject for a paper. Okay.
I think these are all good ideas, but we have to, I think, always recognize that resources are limited. And what we're really about is risk reduction. And to do that, to decide what the best way to reduce risk is to do rigorous cost-benefit analysis. So do you save more lives for a given amount of money by putting kinetic impactors in storage, or would you save more lives by spending that money on more surveys or launching an infrared space-based telescope? And we've got some pretty good risk analysis, risk assessment tools, and those can be used to answer this question. So really, it's an optimization problem, cost-benefit analysis. How many lives do you save for how much money you spend? And I think we really need to approach it that way.
Okay. Yes.
Yeah, just to echo again the launch of a dedicated survey, as Paul Abel mentioned, I'd like to echo that, as well as the cooperation and work with the fledgling commercial mining industry. The main point there is this old adage: when you've seen one asteroid, you've seen one asteroid. We really don't have the database and the information to start making inferences if we did see a threat, a hazardous asteroid. And the more that we can see, the better that we will have to make initial decisions. Certainly, we've got to have that rapid response to be able to visit it. But in coordination with the commercial mining industry, the prospecting that they are going to have to do is completely in line with that characterization at every level, whether it's initial discovery, orbit determination, and general characterization, to getting that database. So the more asteroids we can visit, the better with a cadence of missions and cooperation with the mining industry.
Okay. Very good. Other comments? Lindley?
Well, I was going to hold off on saying this, but this discussion about a bunch of spacecraft and storage and those kinds of things. I think, in a way, the exercise that we had and the scenario we played out was a little bit unrealistic, that we are going to be able to justify sending a fleet of spacecraft. Maybe when the threat level gets to high numbers like 96% or 100%, but I think that's actually going to be a pretty rare situation, that it's actually going to be that high when you know you need it. At the last Planetary Defense Conference, at the end, I stood up and said, now was the time that the community needed to really voice that we needed these capabilities in survey and for mitigation demonstrations. And I think that had an effect with some of the leadership and management of the space agencies. And even 6 months ago, I would have said things are really progressing well. We're in great shape. We've got a couple of mitigation demonstrations that look like they're on their way to getting into development, and a really good chance for a space-based survey to get funded and launched. Unfortunately, all that has pretty much dissipated in the last 6 months. And we are sort of back where we were 2 years ago in having identified where funding and where we're going to get these capabilities that we think are so important to the community and our mission. So unfortunately, I've got to make the same plea this time, is there are some very key capabilities that are needed to perform this mission. And one is a much more capable detection and tracking capability, i.e. space-based, because every study that we've looked at and doing it from the ground, it just takes much longer than we would really like it to, on the order of several decades. To do it from the ground, even if you have large aperture telescopes, 8-meter telescopes doing it. The space-based capability is much more capable of doing that. And plus, if you do it in the IR, you also, as you're discovering them, get good initial characterization information, i.e. the size, which otherwise you can struggle for a while to get nailed down what the size of the object is, and therefore you have not good estimates at all what the mass is. So anyway, to sum that up, we as a community still need to keep our foot on the gas on beating it into the leadership that these are critical capabilities that are needed. Better survey capability and support for doing mitigation demonstration, in-space mitigation demonstrations, because we ain't there yet. And I don't think we can talk about ideas on putting vehicles in storage and all that kind of thing, and the kind of money that takes before we have gotten these kind of capabilities in our
no, I think that's right. Okay.
Toolbox, so to speak.
Yep. Good points. It is disappointing that we're not moving more quickly in those areas. Other thoughts? Oh, yes. Curtis.
So this was the first time attending the Planetary Defense Conference and seriously thinking about what does it mean to defend the Earth from these threats. But what I didn't really see was a roadmap and a final end state that this community wants to get to. Right now we have all these different technologies and concerns that we're tackling, but this is an eternal problem that we'll have to deal with while living on this planet. And I think there is an end state that we need to get to, and I don't see that defined yet. Another thing is, as we lay that out, I think it's important for us to think about what does this community look like 100 years from now, 500 years from now, 1,000 years from now? Is it a few hundred people? Is it 1,000 people? Is that sustainable? And I think it's just like we were saying, we need to entangle ourselves into other industries, other concerns, and it may just be a virtual community, but when the threat does arise, that's when we come together and say, we have all these tools in place, options in place for the decision makers to say, okay, we're going to go with these options to mitigate this threat.
Okay, good.
Thank you.
I think looking out a bit is a really good idea. Okay, anything else? Okay, one more.
I want to raise another point of view. When we are talking about planetary defense, I think we have to think that it's a broader problem. I mean, if we are thinking about defending the planet against some extraterrestrial event, there are some other issues that has to be taken into account. In particular, the colleague from UNOSA has already mentioned there are other initiatives. For example, the Space Weather Initiative that has been being held also in the frame of UNOSA. But space weather or the solar activity, it's another issue that one has to think. And you know that there are many others. So I think that at some point we should try to get together all the people that are thinking about defending the planet. And that involves, well, we as related to the impact hazard, but people related to the solar activities and space weather, astrophysics related to supernova and cosmic ray events. And well, we have some organizations like IAU or where UNOSA and some others that could be interested in discussing these things in a broad sense. So just to remind that when we are talking about planetary defense, we should think that this is not the only threat that we have to take into account. And at some, we know that the different field has different evolution. We have been evolved quite a lot. We have made exercise. I think the people from the space weather community have something similar. In fact, there is a meeting in late July in Boston about the space weather initiative, and that is organized by UNOSA. I will attend that meeting also. And but there are other fields that has not taken this at this stage. So my idea is that at some point we should get together all the people thinking about the planetary defense and think about the problem in a global perspective.
Okay, thank you. Could be a depressing meeting, however. So, okay, well, again, I think we've got some good inputs here, and if you want to provide some more, I think we have all of your email addresses. We'll send out the link. We're going to use the same Google Docs location for receiving comments after the conference as well. And so we'll send that out again, and you can log in and go ahead and add any comments you want to add there. That creates a very nice Excel spreadsheet that we can use for cataloging these things, so that's very useful. I also have a couple of announcements. Number one, let me see. Anybody want to guess what the total number of participants is? Oh, yeah, okay. No, I've got it here, so don't give it away. Okay, anybody want to take a stab? 150? How many? 7? Okay, what a nice thought. We really had good connections there. Okay, well, we had regular participants are 149. We had 43 students and 15 VIPs. Congratulations to them. Total number is 207, plus 11 press. What do you think of that? That's really good. And let's see. I think I have a couple of announcements here. Okay, and did you want to say something about press coverage?
Okay, so in addition to participants, there are 11 companies from press, and TV company, and a newspaper company, and a journal. And already there are several newspaper articles, and NHK, Japanese Broadcasting Corporation, they already broadcasted this meeting. And I think they will make another TV program. Okay, so this PDC is very good opportunity to stimulate this kind of issue is very important to Japanese people. Thank you very much.
Oh, thank you very much. Good. Okay, then let's see, a couple of things here. In your little bags, I mentioned this early on, but you got a little notice about a solicitation for some papers for a publication. Another thing is that we will be having Acta Astronautica publishing 30 to 40 papers, they claim, from this conference. And so we'll need the session chairs to identify the best papers from their sessions so that we can get those in the publication process. And you will likely be contacted by Acta Astronautical to work out formats and things, I would guess. But I'll leave that to them. Secondly, we actually were solicited by a couple of other entities, and this is that thing you saw in your little conference bag at the beginning is one of those. That was an effort to publish a special publication at the end of this year, which would contain a smaller number of papers. And that we need to, my action to them was to work with the International Academy to understand who has what copyrights issues relative to the papers, and so I'm going to let them work that out. That's not so we'll let you know how that goes. It could be that maybe some papers would be used there as well. I can't say at this point, so I don't know. And the third one is there is a group that wants to basically pull together the best papers from all of the conferences we've had to date. And so that would be quite another one. And again, there are copyright issues there that need to be resolved. So again, we'll keep you informed as to how those things go along, and maybe give you an opportunity to either publish a paper now or relative to this conference, plus some others if you've been giving papers before. Let's see. Yes, I was going to say, looking for you. There you go.
Okay, yeah, another announcement. Let me just check. Do we actually have internet here? Because that would probably be the easiest if I bring that up. I think so.
Yeah.
Yes, we do. Okay, tiny. Oops. Does this work? Yeah. So bear with me for a second. But some people asked, so I thought I'd just clarify this here. Okay, it's coming up. This is, well, we do a lot of intersessional work, of course, now, and there's I1 and Same Pages meeting. So how do I get this on to the left? Oh, okay, there we are. So some of you, probably half of you in the room, have received an invitation to another possibility to get us together and discuss this topic at length. There's something called MIAP, which stands for Munich Institute for Astro and Particle Physics, and they have an interesting way of doing workshops. There will be a workshop where we have funding to support people next year in May and June for 4 weeks. And the way it works is that if you're not aware of it yet, you should contact me. But then you go to this webpage and you register for this workshop. Now the workshop is, otherwise I wouldn't mention it here, about exactly our topic: near-Earth objects, properties, detections, resources, impacts, and defending Earth. And it addresses, for example, the point that Alan brought up with asteroid mining and things like that. The organizing committee is Richard Wainscoat, who is here. It's Robert Jedicke. It's Camilla Colombo, who some of you may know. She's working in the field of asteroid deflection missions. It's a guy from Munich, whom you won't know because he's an astrophysicist, and myself. Now, the thing is, the way this works in the astrophysics community, it was a bit new to me, so we were a bit confused ourselves. The way it works is, if you register here, that means you're eligible for being invited. And this MIAP consortium, or MIAP steering group, will select people, hopefully following recommendations from us, from the organizing committee, to actually invite people, and they have funding to support, I think, up to 45 people. The requirement is you have to stay there for 2 weeks. If you don't stay for 2 weeks, you don't get money. That doesn't mean that you couldn't come for a shorter period of time in the view of the organizing committee, but then you don't get funded. We currently built the program in such a way that there is like a little key presentation in the beginning, then discussions in the morning. It's not a conference, it's a workshop. It's discussions, and then in the afternoon, you're free to do your normal job, which all of us, of course, have. Now, in detail, the topics are what we discussed in this conference, plus a bit more. We will talk more about characterization of objects, about asteroid mining and the link. And then the last point is important. It will provide input to I1 and Same Page, and I think that's very timely because this thing ends just a week before the Unispace Plus 50 conference. So if you're not yet on the list, either contact me or just Google for MIAPP and asteroids, and then you'll find it. Thanks for having me. Good.
Good. If you want to send the link, I can get it out to everyone.
Okay.
Yeah.
I'll send it to you.
Okay. Are there any other announcements or comments anybody wants to make? You know, otherwise we might have to adjourn early. I'd really hate to do that, though. So, any thoughts? Okay, Gerhard or Brent, you have anything else? Probably not. Okay, good. Well, in that case, let's adjourn. Thank you all for coming. And thanks for your help in making this a great conference.
Thank you.
Oh, sure.
Yes, thank you, Bill.
Oh, sure. Thanks.